Hello, everyone. Yep, we are finishing up with GLTF pack today, and yeah, pretty much that's what we're going to be doing. Let me just get open the chats in both Twitch, which is... Oops, I haven't changed the title in Twitch. I might be able to do that in OBS, maybe? Nah, probably not. Okay, I'll just edit that real quick in 1 moment. Let me just get the chat. Hi, 214. We should be on part 3. Hello, YouTube Chatteroonie. So I have changed the things in YouTube, so I've been good here. But not in Twitch. Right, let me just fix that. 1 moment. How do I go to this? I think I need to manage the stream, which is here. Manage stream. And then I can very much quickly... Yes, edit the stream info. Cool. Everything else is chill. Alright. Nice. Right, so for those who haven't been here recently, we have been doing a bit of... let's bring up Visual Studios. We tried to optimize the loading time of things by using KTX's library to load in KTX2 file formats. We got somewhere last time. We can actually load an image with KTX2. The problem is the KTX2 file that we end up loading. Let me just turn my music down just a touch. It's very loud for me. There we go. Yeah, I can say, I guess this is game development related. Okay, so yes, we have loaded the image that GLTF pack has packed for us, but because we use the -T C in GLTF pack, it has applied the super compression, which is the... What is it called? Basis Universal Super Compression. So that is, if I go to here, super compression. Yeah, this thing, right? This is the actual library that worked out the compression. So our files are compressed with this Basis Universal Super Compression thing. It's in the KTX2 format, which is fine. Now, the problem is what we're having right now, anyway. The next thing that we need to fix, and try and get this at least working a little bit, is that when we load this image, which loads completely fine, when we try to actually do something with this image, we get the initial format is undefined, which is, you know, a big indication that something's wrong. And even when I set the VK format, we get a validation error further down the line. For this particular type of texture, is just not appropriate effectively. So yeah, that is what we're going to be trying to do today. We're going to be trying to figure out how to get this to work with the super compression. We're gonna try and get this nice working, and after that, I think I'm gonna stream continuous after this point. But we have found an issue with my code, and that's to do with the allocators. So I've written like kind of really basic allocators in memory.h effectively, which are fine. There's nothing wrong with them, but they're not thread safe. And part of the problem, perhaps, I actually don't know. We've got a bunch of white space here we don't need. Actually, we've got a load of white space. Why have we got so much white space? Let's get rid of that. Right. How do I... Okay, it's just in one place. Okay, cool. Very weird. Okay, so we can get rid of these pointless white spaces. There is a motivation to getting rid of white space. Actually, yeah, we can just get rid of more. And replace with nothing. Yep, okay, so this is just a bunch of noise. Right, yeah, you wouldn't want to... lots of white space can throw off compilers. So sometimes it's good to like turn on white spaces. But anyway, that's a side tangent. We have these allocators, but they're not thread safe, which, you know, we could just do a... you know, for anything that uses malloc, we can just use a lock-based approach where we just say a standard guard, standard lock guard even, at the beginning of the function when this thing is you know, allocated, and then we can just be like, all right, safe, all right, cool. Now that's fine, but for stack-based allocations, you want it to be lock-free, which means we don't want to use lock operations. We want to use atomic operations to help with the speed of the allocator. The problem is, I don't know how to do that. And, you know, the more I think about it, the more I'm kind of getting, like, hamstrung by fundamentals when it comes to, not necessarily threading, but computer science stuff, if that makes sense. I'm not talking about data structures and algorithms. That's... I don't know why people are obsessed with them, but I'm not talking about that type of computer science stuff, which, you know, most people obsess over. I'm talking about stuff like, you know, just general computer stuff that I just don't know very well. So I think after this stream, after I've kind of like stabilized the engine, what I'm tempted to do, and I think I will do this, is actually not do any game development for like a small while, and spend a load of time studying stuff to catch myself up to where I need to be. I've already started doing this with maths. I don't stream that because it's kind of boring. I can imagine just writing a bunch of stuff down on a piece of paper that you guys can't see. And that is honestly to help with shaders, right? Now my maths is extremely rusty, so I'm going like super basic right now. I'm going through elementary algebra, just like, but instead of just like watching videos, I'm actually doing the actual maths, right? I'm actually writing down stuff. So we might end up going through a bit of like a study phase where we can actually just try and level up as a programmer, rather than strictly do development. And I don't mind doing this. I think every now and again, it's, in my opinion, a good idea to spend not too long, but some amount of time, basically sharpening your axe, right? I think there's a saying. I don't know exactly how to quote it properly, but I think it goes like something like this, right? If you give me 4 hours to cut down a tree, I'll spend 3 hours sharpening my axe, right? So that's the idea anyway. So we want to get to a point where our axe is definitely sharper than it, than it almost needs to be, and I might not even implement a lock-free stack allocator, which is this guy here. This is the unthread safe version, because it just literally has no locking at all, or no atomic operations. So it has a bunch of like operations that just happen. Again, another chunk of white space. Let's get rid of these. Anyway, but I wanna like level up as a, as a programmer. I think it's kind of rich of someone like me to not push themselves to develop their skills when I have a video online telling people how to become experts, right? So, if I'm not following my own advice to reach those levels, right? It's like, is that video even worth anything, right? If I tell you guys to do things like study C++ well, and then I don't do what I need to study, which is, you know, a bit more. It's not C++ necessarily, but it's you know, a bunch of like, you know, maybe it's maybe I like go back to Casey Moratori's performance aware course, and do a bit of that as well as like getting better at this kind of, you know, understanding memory better than I currently do. My memory skills aren't like not too bad really, but yeah. The downside of this obviously is the fact that things will take longer to develop. But I think you know, there's a difference between sharpening your axe and taking 1 hour to cut down a tree, right? Versus spending 4 hours, or like 3 hours and 50 minutes to cut down the tree with a blunt axe, right? You know, I technically finish faster if I just keep drilling this over and over again. I keep doing game development forever. But I think there's a saddle point, right, where it starts to not be worth it anymore, to just kind of like, all right, I need to work on what I'm bad at, and, you know, get better that way. So that's my plan going forward, I think. But for now, we need to clean up the actual code because I don't want to leave it in this state. It's a bit of a mess. So yeah, that's what I'm up to. We'll see how that goes. I am aware as well, just a final thing, I guess, these maybe study streams, I guess, I don't know what to call them yet, but that I'm planning on doing will be probably a lot more boring. I don't know, why do I say boring, right? Like, Tokyo Spliff, for example, is really exciting to watch because he implements, like, new graphics techniques, and you know, he has like a bunch of things happening on the screen, which is kind of like not necessarily that, you know, a programmer, I don't know, a non-programmer or just somebody who likes video games can like go like, oh cool, something's happening, right? But these streams might turn into, for a while anyway, I don't know how long. I don't think I'll do it for like too long though, so it's completely boring, but we might end up in a situation where we basically get like 1 or 2 views on the stream. But I think that's a worthy sacrifice because, like I said, despite this being, you know, streamed publicly for the public, my main priority, honestly, outside of making sure you guys have a good time, which is always second to becoming a better programmer, right? And I keep saying that over and over again. And I stream because it puts pressure on me to, you know, do things fast and well, right? But at the same time, I've got to also recognize that streaming to entertain people while coding can lead me down a bad path where I just always develop the most flashy thing and make no progress, as you know, make no personal development, right? I never sharpen the axe. I'm always cutting down the tree, right? Because, you know, sharpening the axe looks like nothing's happening, right? You know, and, you know, in theory, you would assume that, you know, if I sharpen the axe enough, you know, I'd be able to cut down the tree in like 15 minutes, right? You know, if I hypothetically sharpened it up to the point where it's like a lightsaber or something, you know, maybe a couple of seconds and cut down the tree. So it's one of those things where it's like, yeah, that's what I'm thinking about anyway. I'll stop, you know, rambling as much, but I hope you guys can appreciate that. But yeah, for now, yeah, I can't just leave the engine in the state that it's currently in, because it is bad, right? So okay, let's change to dev, and yeah. Right, so this is where we're up to. We have a success. And I think we have height and width, right? I don't think that's bad. Yeah. Okay, so everything else, though, is just not working. And I need to be able to decompress. The problem is with the KTX library. I don't really know exactly what the decompression process is for basis universal compression. So, I think this is an AI. I don't know what this website is, but it seems to come from somewhere else. Yeah. All right, I'll read through this. At the very least, to at least understand the compression types, because we need to understand that. I think this is fine. Yeah, so this documentation describes the implementation of texture compression using KTX2's container format and the basis universal compression in GLTF sample in a sample model repository. Okay, it covers this. Okay. Okay, so I'm going to take some notes on this in my Obsidian. I think we're actually going to have to do studying, actually, more studying, which is fine by me because I'm kind of in a studying mood anyway. Yes, otherwise, if we don't understand the problem very well, we won't get anywhere. It's going to be a long stream anyway, so it is what it is. Game development can be quite tiresome, but I don't know, what is Deep Wiki? What is this? Because I just hear it all the time. What is this site? So, Deep Wiki AI documentation you can talk to for every repo. Yeah, I'm not going to use this because I don't want to use AI crap. I thought it was texture compression. She's just ripping off other sites. Yeah, this is actually this is probably a better. Right, so as far as I'm aware, we want this compression, not this one. Although it's not too much of a difference, to be honest. I just need to know how to decompress the bloody thing. But I think understanding these two compressions is good. You don't use AI for searching? No. I think, right, so I'm going to see, what's this? The only reason I don't use AI to search is because, okay, so we're loading up a viewer. I'll have a look at that in a minute. Because I feel like the skill of searching for information is a skill, right? And if you don't do that, okay, yeah, this is just a viewer. If you don't keep up with that skill, you lose the ability to do it. It's like arithmetic on a calculator. Like, you can still get really good at maths, right, with being pretty terrible at arithmetic, but I'd rather just be able to kind of parse resources myself. And eventually this is going to hopefully benefit me when I get to the point where, yeah, okay, so this is, how do I decompress it though? That's the question, or do something with it. So, for example, let's just pretend I'm doing something that's so advanced that basically no one's ever done it before. Like, this is when AI completely falls apart for this, even if we have perfect LLMs, right? So, if I haven't developed the skill of parsing resources and being able to search things and make connections in my head with stuff, because I've relied on AI to search everything, I don't have that meta skill, then I'm going to have a tough time. So that's my justification anyway. I don't think it's necessarily good or bad or anything. Right, let me see. So, oh, okay. So we do have some KTX texture code here. Right, okay, so this looks good. Yeah, fantastic. I think this is what we need. Transcode into native. But, you know, I'm not going to criticize anyone for... yeah, but is this got the compression? Yes. This is definitely about the compression, right? Yeah, okay, so what I'm going to do first is go through this, then this. and then implement it. All right, that's the idea. I'm going to keep them in one source note, I think. I don't think there's any reason to separate them off. I'm just going to make two references. KTX... What am I going to call this? Yeah, KTX texture compression. Because this is what we need to know. That's fine. I am aware though that search engines have got really terrible, so I completely understand why anyone would want to use that over search engines. Right, so keep this at the top, kind of 2. So I'm not gonna like I'll never be an elitist over that particular thing when it comes to like searching stuff for AI. Anyway, all right. I just think the skill. I'd rather trying to keep hold of my soft skills as best I can. Anyway, KTX Kronos is an efficient, lightweight container that can format for reliable distribution of GPU textures to diverse platforms and applications. Okay, I think we already know this. The content of KTX files can range from, yep, 2D texture to, yeah, we already know this. KTX files hold all the parameters needed for efficient texture loading into a 3D API such as OpenGL or Vulkan, including individual bitmap levels. Cool. Okay, so KTX2 added support for basis universal supercompression. Alright, so basis universal super compressed GPU textures are only on KTX2. Okay, so let's read this first. Developed by Binomial, this compression technology produces compact textures that can efficiently transcode to a variety of GPU compressed texture formats at runtime. Alright, so this this tech allows us produces compact textures that's can be transcoded to a variety of GPU textures, GPU compressed formats at runtime. Cool. Additionally, Kronos has released the Kronos _texture basis U extension that enables GLTF to contain KTX2 textures, resulting in universal distributable GLTF assets that reduce download size and use natively supported texture formats to reduce GPU size, GPU memory size, and boost rendering speed on diverse devices and platforms. Okay, so when using GLTF models, you can pack the what is it called? Sorry, when using the GLTF models, let me think. Sorry, let me start again. The text, the GLTF extension. Texture basis U, which I think I might bold here, means that the GLTF file model, I guess, model contains KTX2 textures. Cool. Let's put this as U. Alright, so encodes and super compress, and then the GPU compress textures. So we have to transcode them. Okay, that's good. Basis universal super compressed textures in a KTX2 format. So the open source basis universal encoder with super compression produces compact textures for transmission. Why not download the web page as a PDF, annotate that, and paste it into Obsidian instead of paraphrasing and referencing? That's an interesting way of doing notes. I actually never thought of that. The reason I'm kind of like trying to sum it up in my own words is so I can like learn. I know it seems it's just a different way of doing it. I don't think there's like the way you described making notes is totally chill. You know, my ideas though is to when I read stuff, I want to reinterpret it so I can understand it. But I guess annotating it and pasting it into Obsidian is also a way of doing that. Either way, both are chill. Open source tool pack super compressed textures into KTX2 containers that pack. Yeah, okay. So open source C++ and WebAssembly transcode to GPU compressed formats. Okay, so use GPU compressed textures native to platforms, desktop, block, and then mobile. This is ECS2 and all these other ones. We're probably going to try and use block compression. Okay, so I do like this picture, so I'm just going to throw it in here. And then it'll be easier to look at later. So important to note, you should be transcoding the textures into a GPU compressed format, such as BC7 or whatever. Cool. I used to do the same thing, exact same thing you're doing, but it took way too much time. Yeah, I don't know. Specification and key resources. Thanks to the development of the Kronos membership, our passionate developer community, there's a full set of widely supported developer information and educational resources to help you running with KTX. Okay, so that's great. Cool. Actually, I didn't know these existed. So what have we got here? We've got the... Okay, the text is terrible. What is this? Is this the actual... Yeah, okay, so that's... Right, I see. So this like is a more detailed approach. Fantastic. Okay, that's actually really useful. David Goggins of programming. Yeah. Well, one day maybe. I do actually really like David Goggins, so it's actually quite nice. Thank you. He's the probably the only guy that I know of online who talks about productivity in a way that's kind of like considered, I guess, grind set, right? To air quote it, but he's only really interested in figuring out how far he can push himself rather than making money, which is like what everyone else seems to be doing. You know, I only work hard to make money, it seems like. Okay, so this is actually... Right, okay, so this is important as well. Okay, so we've got a bunch of stuff. How to integrate, okay, KTX into your workflow. Okay, so we've got Artisan, a KDX tool, libraries for, okay, so we might even use a different resource. What do we got here? Let's see. This sample as well as the repositories use okay. Which, yeah, so these cannot be supported. What I'm looking for is like a higher quality resource, right? Okay, so obviously this is I think this is just super general documentation on like how, if I was to implement like I don't know, a reader, you know, from scratch, right? It just picks up the image and reads it and displays it on the screen. I think I would need to do this, or write out a KTX file even. Because we got a KTX2 library, right? But what we need here is the meat and potatoes. Right, okay, so it looks like interesting. Okay, so we might have to do some extra stuff here. So I need to look up GLTF pack real quick and just see what type of compression it's using. So we've GLTF packed our thing, right? I think we looked at this before, but it is using, there's two different types of basis universal compression, it looks like. And I don't think it tells us though. Yes. But what type is it? Right, okay, so okay, so we've got TU and TC. Okay, so let's see. We have what's TU though? We have an extra thing down here. There's it's well written documentation, but there isn't much of it, which is kind of tricky. Yes, let's get. Okay, so there is a help. So I don't know what I've compressed my textures into, which is the next step, I think. Oh, I did put it in documents. Yeah. Okay, so hopefully there is some text written in here. GLTF pack -H. Alright, so converts all textures to, yeah. Use UATSC when in, okay. So it uses that version. So it suggests that much higher quality but much larger files. when we're compressing things down, we are using the what are we using then? Let's go back. I can actually look at my notes, maybe. So it looks like yeah, okay, so this uses this yeah, so by the looks of things, we have this guy. We're using this. Unless we decide to say the other ways. Okay, so yeah, I think TC, I'm guessing here, because I don't actually know. But if it's if one format does something else, then the other format must do the other thing, if that makes sense, right? Okay, so I need to write that down in my notes. I don't know where I'm going to put this, but whoa. Yeah, let's put a GLTF pack in here. Make another heading. GLTF pack compression settings. Right, okay. When using GLTF pack to compress your textures, have we had this one before? Oops. Yeah, okay. When using GLTF pack to compress your textures, there are two options. TC, which seems to compress the textures with ETC1S compression, which is the smaller lower quality version. As far as I can see, this is very this compression format is very hot, looks fine. So you would need to experiment to see if this is good or bad for your use case. Okay. Yeah, I'm just gonna get rid of that. It's a bit too much waffle there. Are you on Windows 10? I am indeed, Steve. Thank you for joining us. I will have to move at some point, but I'm being stubborn as I can. TU compresses textures with so a UASTC, which is the higher quality larger files, larger file formats. These when you without these options, you don't compress any of the textures when simply running gltf pack into the KTX container, right? As far as I'm aware, move to Linux Windows 11 is a load of shite. Yeah. Unfortunately, I'm held captive on Windows, considering most gamers still use Windows. I'm on 10 as well. Yeah, I don't mind 10, to be honest. It's got its foibles, but it's not too bad. Okay, so okay, so there's a bunch of testimonials which I don't care about, but we do have a bunch of better resources to mine. Okay, so the next heading, I'm gonna go with the developer guide, so maybe we can just kind of speed run this, if that makes sense. I'd rather do things closer to what we need to do. So here we have interesting. I would have to check a bunch of stuff, it looks like. Right. So when I'm decompressing, I need to compress it into either block 7, block 3 or 1, has alpha. So it's ETC supported, has alpha. So it's much simpler, according to this flow diagram. If ETC 1 is supported, or is ETS 2 spotted? I actually have no idea. And then we've just kind of got to run through this. Is PVRTC1. So yeah, we just transcode to all these or decode to RGBA, which, you know, is unfortunate if that happens. And we are on this, so it looks like, yeah, this is good enough. Okay. Yeah, so let's go through this and all right. So I saw your video how to become an expert at programming. It was very inspirational. Ah, thank you. I'm glad you liked it, dude. Yeah. I hope I can also as well demonstrate that I'm still trying to be that guy who's trying to become an expert with everyone else, if you know what I mean. So I'm gonna try and because I had this like idea, I had this thought yesterday that if I don't try hard enough at my developing as a software engineer, then my how to become an expert video kind of is very hollow. But I'm sure I want to live the ideas as well as talk about them, if that makes sense. So this is why we're so hopefully we'll be on stream for loads of hours, so you can see that live happening, right? When implementing support for compressed textures, developers should be aware of the three conceptual formats. Okay, so when you are trying to support compressed textures, there are three concepts you need to be aware of. Format concepts, I think. Format concepts you need to be aware of. Right, okay, so one. Come on, there we go. Right, container format and explore explanatory wrapper. Explanatory wrapper around the transmission data formats. It describes image dimensions, compression type, how to access the transcode, how to access and transcode the data into a GPU compatible pixel format without a containing container format. Compressed data cannot be correctly moved between software applications. Okay, so there are, you need, I think it's just KTX, right? To wrap the transmission format data. This is just the metadata about a particular I don't know, texture or image, yeah, such as dimensions, compression type, and how to transcode that data into a GPU compatible. Alright, okay, so that's good. Pixel format. Nice. Alright, oops, no, I didn't want to. Transmission format. Okay, so trans. Yeah, I guess I could bold this. Container format. Yep, okay. Cool. A highly compressed representation of pixel data in a layout designed for very efficient transcoding to one or more GPU compressed formats. Right, so this is the highly compressed representation of pixel data laid out in a way that can, oops, do a space there, can be easily decoded, transcoded, sorry, transcoded to one or more GPU compressed formats. Right, cool. Like ETC 1S or UATSC, GPU, compressed pixel format. Alright, swag. Okay, so this is a compressed representation of pixel data. Understood. Yep. By the GPU. Fantastic. Okay. Such as. It's actually good that I. This is a fantastic resource already. Yeah, because I didn't know BCN. I didn't know this. STC act. And EVRTC 1. Meow. Hi, Luxy Dev. How you doing, dude? Right. Just doing a bit of studying. Portable GLTF. Trying to work out how to do texture compression. Portable GLTF to 3D assets use compressed textures stored in a KTX2 format .ktx2 as described by the the Chronos Texture Basis U GLTF extension. Alright, so KTX2 is a relatively simple binary format that can be written or read or written without use of existing software by referencing the format specification. Several implementations are available. Cool. I did I did a online university thing. Wasn't very good, but I do have a degree though in software engineering. Oh man, my mustache. Right. It's been very irritating today. Yeah, so you can read/write dot ktx2 no, wrong. Dot ktx2 stuff with the read writes. Let's do this. Read writes. Oops. And transcode. .ktx2 with the. I'm probably going to avoid the anything other than Chronos libraries. So I'm gonna grab that so I can get the external linkage stuff, which is going to be right, which we already worked on. This includes a binary package for WebAssembly. Okay, I'll leave that. And yeah, okay, the rest I'm probably going to leave, to be honest. I don't really need the rest. Yep. Okay, so there's WebAssembly builds, and then there's Node.js stuff. Okay, cool. Fantastic. Okay, so the block compression is next. And then block-based compression. Right, okay, so fine today, says Luxy, will be a huge milestone reflecting fully reflecting my shaders to automatically create pipeline lines. Ah, okay, yes. So far I kind of did it manually, and it's tedious given 419 shaders. That, yeah, makes sense. I did that originally, reflecting shaders, to then build graphics pipelines, automate, and then I'll cache them after they've been created and all that kind of stuff. The only reason I stopped doing that is because when I moved away from descriptor sets, the graphics pipeline layouts got much simpler. So I didn't really mind like kind of manually making them, but you know, if you have, I understand that the combinatorics explosion of combinatorics like explosion that can happen, you know, of different graphics pipelines based on the shaders that you have, you know, for translucent, transparent, and opaque things, right? Just to name a few, that makes sense to have a pipeline setup that's you know, makes sense, right? Reflection makes more sense, even if you don't use descriptor sets. And so I might end up doing the same thing at some point, where we just where we reflect things. But I'm glad you're making progress, dude. Yeah, because it was someone early on, I think it was Ratchet actually, like months ago, was like, why are you trying to do reflection when you have like 3 different graphics pipelines? I was like, that's a good point. Yeah, there wasn't really a good use for it at the time. Anyway, to support random access, compressed textures are usually organized in blocks of the same size. Basis Universal always uses blocks over 4x4 pixels. Okay, to support random access, compressed textures are normally organized into blocks of the same size. Basis Universal always uses blocks of 4x4. Nice. Okay. To calculate the number of blocks for a given texture, e.g. estimate the required GPU memory, applications should use the following expression. Okay, so to estimate the GPU memory required for a given texture, you should let's think, use the following expression. Right, okay, let's write that out. Alright, I'm gonna kind of write this out not like that. In fact, I'm gonna steal this and then write it out differently, because it is kind of ugly. So width of block, oops, uint 32, height of block, and then with the pixels +3, and then just these multiplied together. I think that's fine. I think these might be kind of block count. Alright, cool. Well, when you have 3 pipelines, you're in good spot actually to do them. Imagine you're writing shaders stuff when you have a bunch. Yeah, that makes sense, I guess. But either is fine. Make it 420 shaders, so it'll be fun. Yeah. That's what you need to do, indeed. Yeah, but right now, because I've abstracted a bunch of like stuff, I don't think it's too bad, even if we did end up scaling up to a big number. Because there is a, it's not, I don't know how much the cost is. I'm not going to say it's bad or anything. But doing SPRV reflection is not free. But it makes sense, obviously, for people, especially if you have hot, if you want to reload shaders and stuff like that. There's a lot of good reasons to do SPRV reflection. So I'm like, can I get away with not doing it? We'll see. We'll see if I end up eating these words in a couple of weeks, maybe months. Who knows? You use slang, nice. Applications should expect the dimensions of the base MIP levels are 1, 2, or multiples of 4. Okay. Imports that do not follow this restriction are invalid and should be rejected. Okay, interesting. Applications should expect MIP map levels. I say MIP levels, to be honest. MIP levels to be 1, 2, or a multiple of 4. And if that's not the case, you should reject the texture. Okay. Is the stream lacking for anyone? Much recommend. Yeah, let me know if it. I can. Let's just have a look. I think there is more latency. I have both Twitch and let me look at YouTube. Actually, I think YouTube's actually better at telling me this, just on off rip. Right. So stream setting. No viewer. No, what is it? This? No. No, it's this one. I think. No, it's not. So we got excellent. We do have low latency on, so we don't have ultra low latency. But that, if I have ultra low latency, we lower the quality of the stream. It seems okay. So you know, give us a refresh and let us know if that's still an issue for you. But apart from that, I don't really know how. Yeah, I don't know. Anyway, right, let's get back to it. Right, let's keep going. Right, so the dimensions of the sequential MIP levels follow the rule of truncating division by 2. Okay, so I don't know why we need to know this, but this is fine. The dimensions, no knowledge is wasted. Maybe it's just you. That sucks. Yeah, I don't know why. Yeah, 120 and it's still lagging. Of subsequent MIP levels. I'm just going to write this out as is, because it's not really. How can I reword this? Actually, I can just say truncates. So this is just standard things. Truncate, follows the truncating division by 2 rule. Okay. Yo, we met our follower goal on Twitch. Thank you for that, guys. Very much appreciate that. I think as long as no one unfollows, which is, you know, completely fine. I'm not gonna jump up and down and you know, that kind of stuff. We should be an affiliate at the end of the stream on Twitch, which is nice. I don't know what that exactly entails, but yeah, I'm gonna. So yeah, thank you for pushing me over the edge there. That was actually a real milestone that I was trying to reach. I think that does unlock a couple of things like channel points on the Twitch side, which is cool. I should mention people on the YouTube side. We've already done so much good stuff for us that I think we've pretty much unlocked everything on YouTube, which is fun. So yeah, we're repeating the same process on Twitch again, where we're trying to unlock all the individual things for our stream and stuff. So, but there we got there in the end, yeah. Right, can I just steal this because I want to try and yeah. Okay, so I'm gonna just copy each line. I think that's gonna be faster. Yeah, I think. Yeah, let's just do these one at a. Whoa. There we go. This is actually good to know because I don't think I've ever studied the truncation rule of MIP maps, to be honestly. So I know I've done them before, where I do an integer division, but like it's actually nice to see the actual maths breaks down, right? So this is actually kind of cool. So I'm kind of excited to see. Yeah, so the division by 2 here, division by 3. Integer division means we just round down. And yeah. Right, okay, so 2, 3, 4, 5, 6, 7. Fantastic. Okay. Let's see. It hangs sometimes for a couple of seconds on my end. I thought it was YouTube. Does it happen for you for Primal? Oh yeah, I actually, yeah. I might turn off low latency and maybe get a high latency or something like that. I'll look into it perhaps and see if there's a way to like help. Anyway. Fantastic. Okay, here is the base MIP levels. Okay, so here the base MIP level fully fills 25x 50 compressed blocks. The following levels have some padding to fill. Okay, one use pixels in the compressed block. Such padding, when present, does not affect the texture coordinate wrapping and cannot be accessed during sampling. Okay, that's good. Okay, so you can have a 25x. Sorry, you can have things like you can have MIPS levels like which fill up an entire compressed block, but oops, but that's not always the case. Right, let me think. What do we want to say about that? Compressed blocks, such as padding, when present, does not. If sometimes you need to pad data, but this is not present when. Sorry. These pixels cannot be accessed by the GPU. Sorry, by sampling. Hello, Theodric Willow. How you doing, dude? Sampling. Alright, cool. Some older platforms, such as WebGL1, may require all textures to have a power of 2 dimensions. In this case, applications have no other choice but to decompress and rescale textures that do not have the power of the power of 2 dimensions, thus losing all the benefits of GPU compression. Okay, so we're going to assume we're going to target stuff that's above this. When was WebGL 1 out? Let's just see. It's like let's just see roughly what we're talking about, right? So is there a version? Okay, so 2011, right? I don't think we need to worry about that kind of stuff. I'm sure there are some hardwares out there that doesn't support this, but this is even an older, like WebGL is like a stripped back version of OpenGL. So considering we're on Vulkan, it's unlikely that because of if you're on Vulkan, sorry, if you have Vulkan, that you don't have this. I think this is like a old school thing that we don't have to worry about anymore. By the way, kind of like that you're planning / documenting, so many people actually don't and hunt bugs later. Yeah, yeah, it's like I'm gonna I think transition more into this today. After this, I was talking about this as well. Thanks for that compliment, by the way. It's lovely. But yeah, if I don't understand the problem that I'm trying to solve, then all things will go wrong, right? That's the idea, right? You know, if I don't, because I didn't understand that you're supposed to decompress it into, sorry, you're supposed to transcode your compressed textures into a not RGBA 8 format, but into one of these formats that that are supported by the GPU that you're targeting. Like that's something I didn't know, right? Before I did this, and it's like I don't want to like try and do stuff that's bad because I haven't read into stuff. So yeah, it's basically summing up what you just said. I don't want to accidentally make a bug or terrible software because I just didn't read the documentation. Right, so basis LZ codec. I do worry though that sometimes it is a bit boring, but at the same time, I can't become a better programmer if I'm always just slamming my head against the wall, and never like improving my conceptual understanding of what's going on. Right, anyway, I think I touched on that in the how to become an expert video. Maybe I didn't. I can't remember. But yeah, learning requires two general massive things, which is conceptual and procedural. And I feel like my procedural knowledge is outstripping my conceptual knowledge at the moment. So I need to read the documentation properly. Anyway, the ECC1/basis LZ is a hybrid compression scheme that features rearranged ETC1S texture blocks with a custom LZ style lossless compression. It achieves very high storage / transmission efficiency by prioritizing luma information. Sure. Thus, this codec is suitable for color textures, albedo based colors, rather than arbitrary non-color textures like normal maps. I see. After decoding LZ compression, ETC1S data could be lossless repacked as ETC1 texture blocks or transcoded to another block compressed format. I see. Okay, so yeah, so that backs up what we're going to be doing here. We're going to be trying to decompress into ETC1 RGB. Or maybe ETC. We're going to assume it has alpha. I don't know. I don't exactly know how we're going to sample over this. All right. Slash BSS. Right, I think we've heard like Ratchet and Clank to death, so I'm almost tempted to remove some of these. We have a lot of the same. Okay, stop. Pause for a minute. We have a lot of the same music. I do like this, but I've only got 378 tracks, so it's kind of a big proportion. So what I'm going to do is let's go through sequentially. Through a bunch of tracks until we get bored. Where should we start? Yeah, what I'm going to do is, yeah. So instead of randomizing, yeah, we'll go through all these, go through all that, go through all that. Okay, so that's what I'm going to do. We can go through these as well. Why not? Cool. Cool. There we go. 25 followers. Hell yeah. Nope. That's where was I? Lost where I was going. That's the maths I was doing earlier. Alright, let's get back to this. Hopefully that's okay. I don't know if there's any like Ratchet and Clank lovers in chat, but I do get sometimes a bit tired of how much Ratchet and Clank music I put in back early on. I need to add more cool video game music into the playlist so it gets more balanced. You know what would be good? Right, I might do this off stream. I think I'm going to do this off stream. But I need to be reminded that I need to add some Donkey Kong Country music in, because that I think I've got one track in, and there's no way I should put way more in, you know? Because that is peak. It's one of the peak soundtracks of all time. Easily in the top 100. No, it clears that any day of the week. Anyway, okay, so this is a hybrid compressed format. Is a hybrid compression scheme that rearranges. So it's actually quite interesting. It's etc ect 1s texture block. Oops, texture block data with some LZ style lossless compression. It achieves high, yep. So it prioritizes Luma information, which gets a very high storage / transmission efficiency, for things like color textures, it's not as good for things like normal maps, but I'm sure it's fine. Which I hope is true. Okay, so after decoding the LZ compressed, so yeah, after decoding the LZ compression, you can losslessly you know what? I'm in the... Sorry. I say Donkey Kong Country. Why don't we just bloody put on the like a Donkey Kong Country playlist? Like right now. Hmm? Yeah, while we're chilling. Yeah. Yeah, let's just stick on this. Right. While we're coding. While we're going through this documentation. Just turn it up a bit, it's a bit quiet. Okay. Let's get the levels right. Okay. Yeah, that'll do. Let me know if that's too loud, too quiet. I can always adjust. Wait. Right, okay. Repack into etc1 texture blocks. Or transcode into another block. Format. Right, cool. So the data layout ECECT1S represents a subset of ETC1, so compressed data usually has 3 color channels internally. To support use cases that other than opaque color textures, compressed data may contain an extra ET1 slice. Okay. ECECT1S, I'm just going to call it, data format is encoded in the KTX2 container. May have 1 or 2 of the channels entities. Right, okay, so what do we have here? So the first slice is this, the second slice is that. So it's color textures with, and that's just pure red. So it's red, green, dual texture. Okay, so there's, so that is, or red, green. I don't know about, we don't really have red, green. We have blue, green, basically all the time. All right. ICT1S. What I'm talking about here for the blue green is the metal roughness texture, right, for physically based rendering inputs, so we can actually do our specular mapping for lighting. We do need a blue green texture for that. Sometimes we have red in it for occlusion, but that's not always the case. In fact, most of the time it's not the case, so I'm not entirely sure how it would be supported. I'm assuming it would be blue and red. Sorry, blue and green. Just BBB and GGG, I don't know. Anyway, that's fine. This is the data layout anyway. Yeah, let's make another heading. Hello, Ratchet. I'm doing my learning about texture compression, which you seem to have become an expert on. For ETC1S. So I'm learning about how the data layout for ETC1 compression is. And we're also listening to Donkey Kong Country because I kind of got sick of Ratchet and Clank music. Okay, so this represents a subset of ETC1. So compressed data always has 3 color channels. Oops. Which is cool, internally. I don't know what you compressed your textures with, Ratchet, but I'm assuming you did something like ETC ECT1S or AUTCS plus ETC1S. I think that's the compression type. And then transcoded it into something that makes sense, like some block compression format. Some cool swagness like that. Right, internally, okay, yeah. Do you support cases other than opaque textures? Yeah. Do you support textures other than? Yeah, it is, yeah. It's a super compressed format. That's what I'm trying to deal with right now. I'm trying to deal with super compression. I wonder why it's called super compression. Is that because it's compressed twice? With LZ on top of ETC block, Act 1. I don't know. It's like they're in different. I'm kind of learning. I'm kind of like a noob. I don't really know much yet, but we'll keep going. Do you support textures other than opaque? Color textures. ETC1S might contain an extra slice. Now I'm going to do something a bit bold here and just be like, alright. So, this means that the ETC1S data format descriptor in KTX2 container has one or two different channel types. Oops. Super compression formats are super compressed formats can be converted to GPU native block compressed formats decently quickly, like block compression N or ASTC. Yes. So that's what makes it a super compression. Thank you. I didn't really know what the definition was, so. Oh, yay, that just adds in. Fantastic. Alright, so I think we got a load of white space because of that. We will change the word color to the correct spelling of color with the U in it. I will not have anyone in chat challenge me on that. Cool. Okay, so I assume the compression formats. Right, fantastic. So it looks like yes, it's in the same markdown format, which is nice. Oh yeah, of course, there's an MD file. Of course, there's a markdown. Isn't it used in Britain? Where was color? Yeah, exactly. Everywhere else in the world, I think, pretty much uses color without a U, which means that always, no matter what, it's pretty common that when we use a library, it has the word color in it, it's the American spelling, and that's the way with Vulkan. So yes, rewrite Vulkan when. Imagine that. I'm gonna rewrite Vulkan because I hate the way they spell color. That's the only thing. Usage. Okay. Fantastic. Desktops have BCN. Mobile has ASTC. Shipping super compressed formats lets you use the same assets on both. But transcoding isn't free, so I built my cache format to avoid doing it on subsequent runs. Okay, right. How is it? How expensive is it? Do you know, like, how slow is it for you to do? Now, when I show you code, I make sure to spell it color with all caps. Oh yes, fantastic. Blasphemy, blasphemy. And I'll have to put a, I'll have to correct everything. Saved about a second on my test scene, I think. Wow, a second is impressive. Interesting. So that's what you were doing. You were transcoding it into BCN, whatever. And then... So it isn't free, but it's noticeably slower. But I'm assuming after a slower load, even if I don't cache the data, it's faster to render, right? It was the slowest part in my profiling lore, I see. And you were doing a lot of threading work, weren't you, to convert from one type to another? I'm hoping the library is going to, like, not completely choke on this and not make everything take 10 billion years. Because apparently ETC2 is what I should be converting to if I can, according to this flowchart. So we'll see. But I'm just going to keep learning today. It's going to be a bit of a educational. If I can honestly transcode to RGBA, the standard, taking that super compressed format and just doing it to RGBA, I'll call that a W today. I'm not going to try to do everything all at once. Right, that's fantastic. That's actually good to know. Thank you, Ratchet. I was hoping that I wasn't just the reason I asked is because I don't want to worry about the fact that this is going to be slower to load, slower to render, and the only reason to do this would be to use the same assets across mobile and desktop. That would be a big mistake. That would be a waste of time. But the fact that it's rendering faster is good. Cool. I was just making sure because I know you've done this more than I have. Anyway, so using ect1s and basis lv data comprises. Sorry, Twitch chat. This is all in the YouTube chat. I still need to get a bot to combine them both. But yes, I'm streaming on both platforms. If you're wondering who I'm talking to, those on Twitch. I do have both chats open though, so if you are there, I will reply if you do want to say something. Maybe not immediately. Sometimes I'm in the middle of a sentence or something, like reading. Using etc/basis lz, data comprises of 3 steps. Okay, so using ect1s/basis lz, data comprises is made up of 3 steps. Alright, 1. Okay, initializing the transcoder with with common data to all texture slices. What? Faces array elements MIP levels. Okay. Note in KTX v2 containers such data is stored in super compressed global data block. See basis lz global data and basis lz bitstream specification for more details. Right, so first thing you need to initialize the transcoder with data common to all parts of the texture, faces such as texture faces, rays, and MIP levels. Cool. I'm not going to write that note. I don't really know what that means. Block 7 is 4x smaller than RGBA. Wow, 4x? Jeez. It's faster to render with block on desktop because each texel is much less memory. Lol. Fantastic. Wow. Well, there we go. 4x smaller is a lot better. Calling the decoder with... what about... I'll read about it in a minute. I'm asking questions when I just need to read. Calling the decoder with slice data and the texture target texture format needed. Older games use BC1, which would be 8x smaller than RGBA, but the quality is terrible. Right, yeah. I've heard block 1 and 2 are pretty dated. According to this, yeah, you would only do that if block 7 isn't supported and it has alpha. And it doesn't have alpha, sorry. Block 3 is for alpha. And if that isn't supported, then you do PVRTC1, which seems like the oldest thing on the planet. So if nothing's supported, then you go to this. Okay, so this is for... So RGB, this is straight for red. And this is for red-green. What on earth is... Block 5 about? I hope that red-green is also supported for... Oh, that's true, yeah. We're not going to use this format just because it's going to be... I'm going to stick with 1. Yeah, we're probably going to avoid this particular type, so we can just deal with 1. By old, I mean GTA. Oh, okay, that is old. Okay, that's good to know. That's like that PlayStation 2 era. Got you. Okay, upload. Uploading the transcoded data to the GPU. Fantastic. Okay, so when the texture uses a non-linear sRGB encoding, virtually all color textures do that. Applications should use hardware sRGB decoders to correct filtering. This can easily be achieved by uploading compressed data with the proper texture format enum. See the specific values. A single red and dual channel red-green textures do not support encoding. Okay, so when the texture data uses a non... Oh, here we go. Here's the killer music. sRGB. Encoding. Virtually, yeah. Which is virtually true. For all textures. That application should use the hardware decoder to move to sRGB. You can assume that all the okay, block 7 formats are supported if you're working with a hardware that isn't 20 years old. I see. So we can basically go, okay, we can only worry about these 3. So it looks like the only downside is if we go this path, we have to kind of query multiple times. Whereas if we have this time, it looks like alpha and non-alpha could be encoded. Like straight up. I wonder why it wants SETX. I think it said earlier, didn't it? It says like you have lossless compression if you do lossless because you just repack the textures. But not everyone has that. All right, so let's just go through this, right? Yeah, block 7 supports alpha and non-alpha. That's really cool. Right. By design, ETC1 is a strict subset. Right. Okay. Of ETC1, so transcoding to ECT is always preferred. Single slice textures should be transcoded to ETC1 RGB, while dual slice textures should be ETC2 RGB. Got you. Thank you, Ratchet. I might actually write that in. Okay, so it's going to easily be achieved. I don't think I've written this in. Yeah, you just need to correctly select the right enum. With proper texture format enum. Yep, okay. Note that single red red and red green don't support sRGB encoding anyway. Right, cool. Fantastic. That's quite simple. So the first thing we need to do is just set up the transcoder, then we just do the encoding and then upload the transcoded data. Right, cool. Oh wow, okay. Right, so blocks, yeah, okay, that makes sense. And some special encoding. Normal maps is for 5. Block compression 4 is for height maps and grayscale images. And block 6H is for HDR textures. Okay. Right, let's write all that down as well. I kind of pair what you just said there, Ratchet, with this. That's all of them that are useful these days, I think. Okay, got ya. Do you check for ETC1 RGB and RGBA, by the way? Or do you just go straight to block 7? Out of curiosity. I would love to know that. Transcode target selection. For RGB and RGBA. Just because of this paragraph right here. By design, the ETC... So I'm just going to write this out kind of because I already read this. By design, the ETC... Oh, I actually don't know what compression format you're using, actually. 1S is a strict subset of ETC1. So transcoding it to an ECT format is always preferred, according to this documentation. I don't care about super compression formats, so I just tell LT lib LTX to transcode it. I see. Lib RTX optimizes transcoding routines. Got you. I was hoping that's the case. I didn't want to actually have to do that myself, but at least I know I can query these formats and then kind of figure out like what transcode I want to do. The problem is I don't know if we have alpha, which would be kind of awkward if I didn't. Yeah, so it looks like it looks like we'll never end up over here, which is good. I think I can cut this tree off. This is encoding time decision, not a decoding time decision. GLTF has this. No, I meant ETC 1 RGB. How would I know if a texture has alpha then? Oh, okay. I don't know about that function. There's stuff like that I don't know. KTX2 texture transcode basis. Excuse me. I just got a text or something. Alright, nothing. My mobile provider's telling me about it's just giving me an advert. Anyway, so you're so what is that? I'm kind of curious. Let me break from this because I'm kind of curious if the KTX2 library even supports this type of thing. So let me think about this for a minute. So the KTX2 texture to transcode, because I wonder what it does. Like, does it always go to block, or is it something that does it work it out? Is it good for us? I don't know. All right. So we might have to encodes and compresses KTX2 textures with an uncompressed image to 80. Okay, so it looks like we just select the one we care about, maybe. Okay, so it encodes. What have we got? I don't really see anything. Oh, I did the wrong thing. Sorry. I'm on compressed rather than transcode. Where's the transcode one? That's compress. Is this it? Yeah, just bear with me, guys, while I just try and figure out exactly what this function is. Okay, so it's just basically here. So it transcodes into a native format, and then the target format is this. If you select it's a transcode for a UTC UA blah blah blah. Okay. You check it. Okay. Right, so let's just have a go. I'm going to write this in, I think. This is going to be quite interesting. But I'm kind of curious now. What ends up happening with this? Because I think this will help me kind of understand what's going on a bit better. So, target format. The second thing is a enum. So let's get this out. Kind of throw this here and say, okay, format selected, I guess. And that goes in here. So I assume it's an output variable. And we have a result here, which is, I assume, the same thing. Yep. Okay, so code. Whoops. Oh, for goodness sake, stop double clicking mouse. My mouse has got this terrible habit of just like clicking too many times. It's really annoying. Even though I've turned down the sensitivity all the way I can, it still does it. Alright, so could not transcode image. Okay, so let's just have a go. You missed the transcode function, it's right there. I linked it in the resources. Okay, let me just check. Right. Okay. This is our little Discord server. Yeah, didn't I do that? Or am I just... Right, I think I did. I think we just maybe the stream delayed. Yeah. Thanks for linking it though. This is actually going to be really useful. So, okay, so that does this, which is fantastic. Oh, this is actually better anyway, because it's got more documentation here. So it's going to tell me what it's in. So I assume it's this one. We'll see. So let's do this. We'll see what it comes out as. I'm in solidarity with you. I'm in the kitchen right now. Hell yeah, kitchen bros. Oh, oh, I've got a runtime error thing. All right, this is just a simple copy and paste change. So void error. All right, cool. It was another error, but I think it's the same. So we have a... Okay, let me add that in real quick. Where does that come from? If I open up Notepad++. Alright, so... Why aren't you... Oh, okay, there we go. So this exists in the transcode. So we need these two. By the looks of things. Yeah, that makes sense. We need the transcode code. Right, so let's add that in. And that is... Oops. Excuse me. Lib... Yeah. And it's called... Can I just copy this? This would be fantastic if I can. Throw this in here. Yes, cool. And maybe... I don't think I need the N code, but I'll... Do I need that? Nah, we'll see. And we should be able to build this, unless there's some other issues that are missing. Nope. Then we build this. And we are missing... Yeah, we probably need the encode stuff. So, duplicate. What else? Encode. Right, let's do this again. One step at a time. Do we have everything here? Error, redefinition of enum. Maybe we didn't need encode. Yeah, let's get rid of encode then. We should have just looked. I should have just looked. My bad. If we're not encoding, then why do we need it? All right. Okay. Let's bring back our things that are missing. Reload, and we have a bunch of bases stuff. Increase capacity, maybe. Where are you? You exist in... Oh, great. These def files. Right? Let me just print debugs in here as well. Okay, where's this then? I think yeah. Yes, that's where it's... No, where's it defined though? Yeah. Okay, so there's some other library here that we need to get. It's the basis. Okay, so this is going to be a bit of a faff. Get ready for a faff central. Because this library is split up into like a lot of different other libraries. So there's a basis thing here that we're missing. So if I go to his basis format support. Okay, so this is the most like, I think the most unlikely to collide with anything else. Let's open these up. I think that's the problem. We missed stuff here. Right, okay, that's helpful. No, it's just other stuff that we have. Yeah, okay, so there's a bunch of stuff in here. What are we missing? I think I need to go to the header. Or see what it's included. Yeah, so these guys, where are these at? So, bases... We just don't have the implementation files for these guys. So according to what I need to do then is find where this is. Oops, go away. Double clicking again. Lib basis. Okay, so in the lib file, apparently there's a basis file. No. Basis folder. Oh. No, they're all here. Okay, so encode. We got transcode. No. Why have we only got a couple? I am confused. Okay, what's in this? Just got anything in here that's useful? No. By the way, I just warn you, by the way, transcoding is stupidly slow on MSVC debug mode. Thank you. I will be ready for that. Hopefully, we can maybe decode to ECT1, and maybe we don't have to do anything else, who knows? But we'll see. This might be a fool's errand in the end. And we just might not even do it. Right, so where's the basis stuff? That's the question I'm trying to find. Alright, let's look for it. So there should be like basis files somewhere. Tools, okay. Is it here? BBB? No. Right, I'm gonna do that again. I wish I could see the file name a bit easier. I mean, the search has improved. Oh, basis U. Yeah, but where is everything? This? What's in here? No. external. Okay, that's what I'm probably looking for. Go in external. Where is it? And open up basis U, and then here I think we're missing a bunch of files basically. Yeah, the transcoder stuff. Ink. Interesting. Now what I need to do is, I think I'm going to open this up in, also research this. Nope, guess that wasn't there. Where is that? I'm surprised it wasn't there, to be honest. Alright, so we're going to open up all these as well. Hopefully, oh, hang on. Let's just check what this file is. Oh, get out there, yeah. We need to search everything. Higher up. You can't use ETC1 on GPU. You've got to transcode that. Yeah. Sorry, ETCS1. I want to go to ETC1, not ETC1S. Or ETC2. Or ECT2, ECT1. Hi, Greeb. Yo, what's up? Yeah, not bad. Just learning how to... trying to connect my libraries to work and see, you know... Trying to... what are we trying to do? We're trying to deal with super compressed textures, which means that we have to decompress them, then use a regular compression for the GPU, and fingers crossed that we can do this. Mostly studying today. Right, so tools. So this is basis U external, basis tools. Where's the definition though? Here. Right, okay, so we absolutely need the transcoder. CPP. Which makes sense, but didn't I try to include that earlier? Give me a minute. Oh yeah, I forgot. The Visual Studio is just not allow you to press control, allow you to do undo redo for some reason, which is very unhelpful. Let me think. Yeah, this basis transcoder, right? And if I look at this and I look for that, do I see a definition here? Oh, I'm in the header file. Why am I didn't want the header file, thank you. The CPP file, hello. Okay. Right, let's try again. It's not here. Where is it? I'm confused. Because I'm in the transcoder here and we actually have the implementation. But in the lib code we don't have it? Why? Ugh, okay, let's get the transcoder from here then, I guess. We shall do that, and thanks for the thumbs up there, dude. Garib. Right, so let's grab the external dependency, which is basis U, transcoder. Okay, so let's grab all this, gubbins, and in our CMake code, we're going to try and grab that and see how it behaves. This might just completely break everything, but it might not. I have no idea. But it looks like we need this transcoder because it actually has the implementation in of all the things that we seem to want. So we shall see. And the error was this doesn't exist. Oh, that's I missed a slash. Let's try it again. Both AASTC are well supported on mobile. External. Yes. Makes sense. Yeah, why aren't you finding it? This is slightly irritating. Considering that is the path. I feel like putting the absolute path in just to get rid of that bit. Let's not be stupid. CMD, I might go for lunch in a minute as well. What am I doing again? Oh, yeah. Cannot find this file. Vendor... Right, okay. So this path doesn't exist. What? Okay, this is just a simple mistake here. So, external... basis U... transcoder... and then it's that. So let's grab this... and make sure that... actually... let's grab that as well. It might be not called that. Okay, so it's not. Okay. That was the issue, actually. The file name itself. You can't avoid transcoding if you're... Yes. What I'm trying to do is just make this library compile with this new function. And now we're missing... Oh dear, no, this is... we need both. Understood. Oh, okay, great. Okay. Transcode. No, that's not it. Let me, give me a minute. Lib. I don't know what it's called, so it's just gonna, I'm just gonna grab it. Make sure it's called the right thing. Right, yes, it was completely different. Let's rebuild. Now, I'm a bit afraid now we're gonna get linker errors because there's gonna be redefinitions in two different. Nope, that was it. Okay. Fantastic. Let's go back. I mean, we still could get issues, but let's go to our here and see what ends up happening, because I have no idea what this is going to do. I want to see at least something in here. Right. So needs transcoding. So here's our texture. Here's our thingy. Format selected isn't. Oh, I've got to select the format myself. Okay, understood. So as far as I'm aware, it would like this format the best. If it's not, I think this texture doesn't have any transparency in it. But how do we know? We'll try it. We'll try it. Let's see what happens. Right, I thought it was an output variable rather than an input variable. That's me not looking at the function. Yeah. Okay, got a success. And what does this come out to then? So, ETC block, RGB, blah, blah, blah. Right, okay, so that's actually quite intense. I have literally no idea what that's going to be like. But that hopefully can... yeah. Right, okay. Hello, Kalia. And the YouTube chatteroony. Right, so let's see how this handles our transcoded data. Now I hope... Oops, no. Stop double clicking. That's my double clicking happening. So when we do this data thing, I assume the data changes. So it looks like that at the moment. So it transcodes it. What's the day look like now? Okay, so it is very different. That's actually good. So that looks like, assuming that my GPU supports it, we might get a texture. Actually, we've got a second issue. We're assuming this. We're assuming this is always true. All right, so we've got that far, which is nice. So if you use an ect1, blah de blah. Not that. This. Sorry. Whoops. Yeah. This is. My engine is pretty primitive when it comes to selecting the types. So. RGB without alpha, I don't think NVIDIA supports. Right, let's just see what it said. The VK format not supported when calling. Okay, there we go. Right, well that's gonna simplify things for us. It wants this format, but we can do an A, or no, whatever it was, 2, I think. 2A. Right, okay, so let's do that, right? That's a RGBA format. Thanks for that, Ratchet. That's actually really helpful. So do we get the same validation error? No. Yeah, so that was the issue. It has to always be RGBA. So the transcoding may be a bit slower, but the problem is, though, I've kind of hyper-selected a particular format. Like, how well is this supported? I have no idea. Like, how well is that supported? GPU support. Cup of tea time, yes. That's always a good cup of tea time. Right, so ETXT in a nutshell, GitHub page. That's not what I'm after. We'll be back in a minute. Well, yeah, go get your cup of tea. Gotta get it. The Ericsson compressed. How do I check this? Is it gonna be in the GPU hardware stuff? Actually, I don't think. So this is the device type. How do I check formats? Yeah, this maybe. Yeah. Okay. So when it spits out a what does it spit out? Like, how well is this? I might be just like basically doing something that's like not supported by like basically anyone. Because I've got like a really up-to-date graphics card. So whoops, I need to take that. Thank you. So yes, anything supported for me, but like, oh, where is this? Not supported at all. Where was I? Formats. It's linear? I don't know. Buffer? Is it this? No. Alright. GPU support. Like, what is this? Who supports this? Yeah, so there's a form. Yeah, so it definitely exists, right? Yeah. There's sRGB block. Okay, so it's come back as sRGB. How supported is it? That's what I want to know. Remove the VK. Thank you. I didn't notice that. I was making that mistake. Right, okay. For... Nope. Optimal tiling, I assume. Yes, you're right. Yeah, there's no VK format here. There's just this. Okay. Let's have a look. So... 60. Okay, so we got 60. That could be just not on mobile though. I don't really give a. So sampled image is what we're after. So this is the most important. So it's going to process that. Thanks for that, Ratchet. I was completely missing it. Okay. I was hoping for a percentage, but I guess I can see when these were made. Let's see all of them, I guess. It's going to be a bit of a low, no, actually, that's just going to take forever. Let's see. And really? NVIDIA? What? Yeah, NVIDIA. Okay, so it's still processing. I'm back. Welcome back. Okay, no, GeForce perhaps? Oh, I might have to go back one, I guess. Did I not do this right? I'm confused. Let's go back then. According to Ratchet, I've gone off the deep end here. So we'll do this again. So optimal tiling, which is I assume what we're after here. We paste this in, we get rid of ict, we get rid of format. Thank you. Oops. Yep. You've got to go back one tab. Vulkan is actually enjoyable. Fantastic. Select Windows. Oh, right. There we go. That's what I'm. There we go. Okay. Yeah, because I don't really. Because yeah, we've got iOS and stuff like that on there, which is ooh dear. What about Linux? Stop it. Just delete that. I need to copy this out. So Linux is a little more supported. What on earth is... Are you saying Mac supports it or something? No, okay, 8%. I was surprised then. What about you? Oh my goodness, really? Basically all Android does? What? Have I selected a mobile format? Interesting. Wow. Okay. Yeah, because this is the only thing I care about, the sampled image stuff. What about... I'm super curious now. 100%, okay. This is like a mobile... Flippin' heck. I love this song. But yeah, for desktop, we are struggling for some reason. Why is it like that though? Is there a reason? I mean, that's just going to tell me the devices, but... So let's see. Is it like super new or just does not get used because block 6 is, or 7 is so much better? Interesting. Yes, this is a mobile format. Oh, okay, is it? Right. Why is this documentation telling me that you should always use this over the other one if it's supported? Yeah, this is the script I'm following, right? Alright, it looks like NVIDIA does not support this anyway, so this is completely irrelevant. But if ECT2 is supported, then use this, right? So I'm super curious, like, why is this telling me? By design, ETC1S is a strict subset of ETC1, so transcoding to ETC format is always preferred because of that. Single slice textures should be transcoded to this, which is not supported. Am I like Mobile Central or something? Like, what is going on? This is not supported on a video, so this just does not work. So there's a piece of information there that I need to change completely. And then we have Act 2 RGBA. Block 7, because Vulkan is also a mobile IP. Yes. Okay. So yes, I think you're. I don't know. Yeah. Okay. I wish it said if on mobile instead of just, you know, declaratively saying a sentence like do this or else. Oh, right below. Okay. Right below. Right below. Right below. Right below. I should. Oh dear. Oh my goodness. There it was all along on desktop GPUs without X supports. Yeah. Okay. Do block 7. Okay. Okay. I didn't know. I didn't know. Yeah. I kind of went, all right, let's just see this, see if this works. I didn't know. You know, you got to remember, I'm still learning this as we go. So there's a lot of like silliness that I'm probably gonna make. So block 7, what's block 7 at? I will check the support on that because I'm kind of curious. So block 7 is the format that we like, which I assume is just there's block 1. Block 3, block 4, block 5, block 7. Right, okay. And this is still a slow transcode. But it does say that. It does say the sentence should be. I don't know. Should I care about this? This just seems like a minor detail. I don't know if it's like faster. Let me just go back to this again. Where were we? Excuse me a moment. Yeah, I don't know. It does say on desktops without this support, do block 7, right? It's like I do believe this documentation is probably it's written. I don't know who's written it, but I do trust them. Block 7 always supports alpha channels. Okay, sure. So it just says 225. On older GPUs without block 7 support, blah blah blah. Texture should be transcoded to BC1 for RGBA double slice. Oh, so we should be on 3. Alright, cool. So I do believe that maybe it's emulation, of course, so it's slower than native format. Ah, okay. Is that why it's slower to decode? Right, okay, so let's just see if this works, right? I kind of want to see... we haven't actually... We're not out of the woods yet, but we have transcoded at least, I think. Okay, so now we're on block 7. Now, I have no way of profiling this at the moment, but... yeah, so that at least is sRGB, and obviously this is not going to work beyond this point. So, but it should do every Vulkan thing correctly. After this, like this is all not going to work, as far as I'm aware, anyway, because we're just assuming that it's sRGB. When we've used a compressed type, it's way smaller. So, I think that's the only issue that we have to deal with. Is if we've used a compression type, we need to work out the size of it differently than just assuming that it's sRGB with 8 bits per channel, which is just, you know, width times height times 4, I think. As far as I'm aware, what are you talking about? Layers? No, I was talking about layers. Sorry, I don't quite understand then what you were referring to. Hopefully you left your demons inside. Well, we'll see. We'll see. Actually, let's just see what happens, right? I'm kind of curious. How does this, like, barf? It's got to be smaller, right? The texture has to be smaller. Is there a way to say size? Ah, right. That might be it. In this... Yeah, instead of... Yeah, hang on. Give me a minute. I think... KDX2... get size or something? No, there's a way to do this. I have this in my notes. Give me a minute. Graphics theory and... No, not graphics theory, sorry, Vulkan. And the texture stuff is... here. Yeah, creating a texture, and I think I just had it in here somewhere. Num levels. There's a way of getting the size. Yeah, data size, right. So at the very least we can do that. Yeah, there it is. Thanks for the help there. Yeah. Alright, so that's as far as I'm aware, yeah. That's what we need to do. Okay. So for this, what we want to do is basically have a... Do we have a size in here? So you have set size, but again, we're assuming that height and width and depth. So I'm kind of curious, actually. Let's just see what these values are compared to each other, because I actually don't know. Again, just let me... I'm just learning, so when I do this, I am saying that the values are... So this is the sRGB X4. I'm just going to throw this in. I know I'm casting to 4. It doesn't really matter for now. That's just 16-bit, sorry. So I just want to see if is there an actual size difference here, which I assume there is, but I've got to see it. So OG size equals this, and now we need the uint32 compressed size. Right. So I'm kind of curious, like what does this actually come out to be? So let's see. So we should have. Let's remove this breakpoint. Right. Okay. So we have. Yep. The format. So the compressed size is that number. Oh. Okay. So that. Let's just see how much smaller that is. That's a lot smaller, I think. I hope. It'd be worse if it was bigger. So let's get the assumed bigger size and paste that in. So it's 1,000,000 divided by. So see how much times smaller it is. Not that, you lemon. Oh, I hate the bloody Windows calculator. Okay, great. This is exactly what I wanted to do. Why not just do it in the maths, right? Literally, I could just be like, all right, what's this? I could just do it in code. Bloody hell. Let's do a float actually. Float size times size. Right. I know this is not a proper way of doing it. I'm just kind of curious to see the differences. Like how much smaller is it ratio wise? So the OG size is going to be way bigger. Does the compression size also includes MIP? Oh yeah, that also includes MIPS. So it's we need to cast that to a float. So it's basically 2 times, but yeah, okay, so that should fix it. Let's do that again. Yeah, so it's basically 3 times smaller. Interesting. Which is kind of cool. So that's 3 times smaller. Jeez, that's cool. That is really badass. All right. So I'm gonna have to rework my texture struct, I think, a little bit. So set size is always assuming one particular thing, but I think what we're going to have to do here is kind of like work out the size before we go in and then do something. I'm also kind of curious though, is the other format size that's just barely supported, which is the etc block version, which I think is a faster transcode, but I'm kind of curious as like, when I do this, again with MIPS, yes. When you use size T for size, or else you'll run into issues later on. I'm just kind of hacking things together at the moment. This is not going to be... Oh, that's a 33% increase. Bruh. Wow, that's incredible. So you don't need to actually generate MIPS. Wow, that's so cool. Wow, this is like... this is crazy. I think the only reason I'm trying to do this as well, the transcode to etc2, is because I want to see, one, is it smaller, and two, maybe I'll measure quick delta and see how fast it is, but maybe not to transcode. Because Ratchet has spent a lot of effort to try and get this to be faster. And I'm just kind of curious if I can save some of that effort, if I can check if you support ECT2 RGBA. Is the transcode faster and is it smaller? But it might not be. It might be poopy. Alright, so might not be worth it though. I don't know yet. So what is it? It is ECT. Yeah, this thing. So I'm just gonna temporarily put this back in because I want to see with MIPS how this behaves and what's the size differences and all that kind of thing. All right. I'm just checking the other formats that my GPU does support, but I'm kind of curious its size difference. So it's basic. It's the same. It's the same size. I can actually kind of throw this here. Again, I'm just so this is the ETX2. So I don't think it's going to matter. It's just transcoding size, maybe speed even. RGBA is that, and I'm kind of curious about the other one. So let's try again. Again, this will be with MIPS. So block 7. So what did you say? You said it's... Yeah, so block... So it's the same. So this is block 7. Sorry, BC. RGBA. So RGB, yeah, so it's the same size. So there's no, I think, as far as I don't know why it's telling me to do this, but I'm trying to figure out why, basically. What I'm doing here is like, why is this here? And why does it say on GPUs that do not support ECT? So it assumes that I've at least tried this to then go to block 7. Why is that the case? Why is it wanting me to do this? I don't quite know. On platforms supported by ECT1, applications should transcode to ECT slices. I do have this. I have compressed it into this particular format. I did check. We have done a super compression to this. As far as I'm aware, when you've super compressed the texture, it looks like it's going to be faster to get it to ETC on the transcode. To improve transcoding time step in one turn optimization, the speed up is stupid. It's written for all platforms, lol. The format was designed around mobile. To improve transcoding time, the transcoding time step, one is to turn on optimization. Oh, do you mean like go into release mode or something? What do you mean by turn on optimization? The speed up is... What do you mean by turn on optimization? Do you mean like to turn on the release build? Then go to release? I don't really understand that. What I'm just trying to understand stuff, Ratchet. It's not like, why does it say that? That's what I'm trying to understand. On GPUs without ETC support, so it assumes that I've tried ETC support. Do block 7. So this apparently, according to this documentation, is second choice behind ETC, assuming that you've compressed in this format. Debug is much slower. So that's what I'm trying to figure out. And if it is significant, this documentation is telling me to do this, maybe I should use ETC 2. Assuming that it's supported. I know you're saying it's a mobile, but there's a reason that it's because it's a strict subset. I don't know. It hasn't said anything. I don't know why this is the case. Why is it the case? I'm not saying that it's right. I just don't know. What I want to know is why. Why does it say that? And I'm gonna have to maybe do a bit of googling. Like, what is this? This is about alpha support. Zaka said, I think it doesn't say that it's better than. That's true. It doesn't say it's better than BC. Because the format and the guide is written around mobile devices. Is it? That would be good to know. How do you know that? Let me check. Does it assume that... Like, what's the assumption here? Give me a minute. Oh, it's an artist guide. Interesting. I'm just going to open that real quick. Wow. Okay, that's interesting. But anyway, okay, so this is just not. I was just kind of curious, like what this was about. Yo, look at that! Got our duck model. Flipping heck, the difference is crazy. Right, okay, so what I'm going to do is do a bit of Googling around a minute. I know you guys are like want me to just do block 7 and move on, but I'm trying to figure out. Although you say this is for mobile, what we were looking at earlier, this development guide, I don't see any indication that it's mobile. I'm trying to be like objective about this rather than I'm sorry if it's a little frustrating for people who are watching. I want to actually know what's going on, like 100%. So just bear with me. So what's the format called again? ETC RGB. Okay, so it's a 16-bit transcoded thing. Okay, so that's very easy to tell if it's on or off. So is it on? Oh, that's actually really nice. So it's not supported in DirectX, it looks like. Okay. Right. Right. Okay. So we can check if it's supported quite simply. It's super trivial actually. All right. So let's look into this texture format a bit. Okay. So the texture Ericsson texture compression etc is lossy. Texture compression. Yeah. Okay, so right, it's fine. Okay, so if we have ect 1s, let me put some music on. I'm gonna probably break for lunch soon because I'm getting very hungry. But yeah, let's put in Donkey Kong Country 2. But the asset should be stored in block 7 directly, right? On disk. Can you store it in block 7? That's a good question, actually. Let me think. As far as I'm aware, if I go back to my notes again, the idea with, you have 3 different ideas, right? You have the KTX format, which tells us the metadata about a particular image, how it should be transcoded into, how it to be transcoded. Huh. Maybe that can tell us something. This is highly compressed. Yeah, it's just, okay. You can store it as BC directly, thank you. Because ETC1 is based on ECT, it's natively supported mobile, so if it supported, the transcode would be faster. KTX2 is made for all platforms, so they would tell you what's faster if your target can support it. So they can't. So they. I see. Okay. KTX2. There's a fly on me there. KTX2 is made for platforms. Let me just read that again. So they tell you what's the faster path if your target can support. Okay, so they can tell you. They can. How? Because I have to tell them what to decode it to. I assume this is just an if statement that goes over this thing. Learning. I've learned a lot today. This is quite good. I feel like I've learned very, very fast. Oh, got some notes here. All right, so for BC, blah blah blah, ECT 1s format, opaque and alpha refer to 2 separate images, aka slices within the basis U data. For U ACT TC format, they refer to the RGB. Yeah, okay. If the original image had 2 components, okay. I'm a bit confused. How do we know what format we want to transcode it to? Let me think about this for a minute. What I'm trying to say is you should not transcode sRGB data to this. Okay, so we're never going to use them anyway. This format, as neither OpenGL nor Vulkan supports sRGB variants of these types. Okay, doing sRGB coding in the shader will not produce the... Okay. Right, that's good to know. That's just some formats we can't use. What I'm talking about as well is yeah, that's what I was thinking. Okay, that's what I want to use then. If it's faster to transcode than if I'm using the compressed version. But I guess here's the thing: if I store it as block, okay, this might be like a big merry-go-round here, but if I use block 7 RGBA, I don't think you use super compression, do you, Ratchet? You just somehow store the images. Right. Okay. Let me think for a minute. I think this is overcomplicated, and I should only do this etc. Okay. What I'm going to do is write a note to myself. I think. Let's just write a note to do. Oh no. Check. No. If transcode is too slow with the etc1s compression type, use what is it called? It's got a, I think it's right at the top, so it's actually quite easy to find. Oh, I didn't play the music, did I? Let me go back. Use the compression type if supported. Maybe there's other ways to make it faster, actually. Or look into making it faster a different way. Okay. Right. Okay, I have a question for everyone who knows about this stuff. If I have an RG, like a blue-green image, like, don't worry if you don't know and you don't want to answer. That's also chill. But this is the open question I have. Oh, what? Oh, I've deleted. No, models out. You see, this is a normal map. Oh, why are you being awkward? Just open it up. And we've got, you know, this, which is a roughness map. Okay, this is opened up in here for some reason. How do I know which block format to use based on that? Right? Because obviously, what was it, block 5? You want to use a block 5 for that. They're telling you in the docs that if the texture is super compressed with etc1 and your target hardware is etc textures, if you choose it, then transcoding will be faster. I can load any KTX2 texture. I just store BC7 version of them in a cache, or if you didn't transcode it, sorry, or if it didn't need transcoding anyway, I just store the original image in the cache. Right, okay. I'm sure, yes, so you do some like cool stuff here. Right, I feel like I'm pretty okay with how we're doing things. Let's just see. Let's just do the simplest thing right now. What I need to do is right. This is gonna break like so many different things in so many different places. But height, width, and depth are fine. We can store them, but we're gonna have to store a uint32 size. Right. I know someone said earlier that size T can be used, but I don't, because I'm using not integers and hard-coded types. Oh, we'll do 64 maybe. No, 32 because we end up casting it anyway. Right, so actually what I'm going to do is I'm going to do a set size. Yeah, okay, so we're going to have two set size. No. How do I do this? So size needs to be equal to something. So size. So in size, yeah. Or new size even. Right, I'm gonna blast through this because I'm so hungry. If I make a mistake, we'll have to do it after. So I'm not gonna fix anything that breaks here. So unfortunately, this is gonna break so many things. So if I had a proper asset pipeline, I'd do more cool things. Love that. Yeah, I feel like I might have overcomplicated everything there. So I'm not too worried about this anymore. Right, okay, so that's going to break like literally everything. Every time we use texture creation, literally everywhere now, we've got to kind of work this out ourselves. So if we are going to... Right, so again, this is not ideal, but I've got to... No. Okay, cool. Let's just pass in the UN 16, I guess. No, it needs to be 32. Size. For here, so yeah. This is why we're not going to worry about any breaking changes afterwards. Texture creation is fine there. This is the thing we need to pass in. Okay, so that's fine too. Okay, here's... No. Okay, so size is... Yeah, size is 1. Yeah, that's all fine, That's all good. Let's keep going. What else? Okay, so this is for a... So size is equal to this. Apparently we need this for some reason. Oh, it's depth. Oh, this is tricky. It's not RGB, it's just that, right? As far as I'm aware, anyway. So if we're doing the depth texture... Right, I think I'm going to actually give in, because I'm so hungry. Right. Did you look at CPM? I don't think I did, sorry. What is CPM again? Let me just Google that real quick. I might have... No, I'm just getting a bunch of business acronyms. Sorry about that. Did I look into CPM? I don't even remember. Right, sorry about that if I hadn't. I'm going to put on a video just to like watch because I'm like about to eat my microphone. So we're gonna leave doing extra coding. Have we opened this twice? It's doing a bit of revision on the maths here. What did I want to... I'm gonna watch Casey Muratori video. I know we're not going to finish it, but I want to listen to a video. I think a good one will be the Microsoft interviews. Like, yeah, these are perfect. Rectangle copy. Flood field detection. Yeah, let's do this, right?
Question number...
So, this was 4 interviews that Casey got when he was trying to be an intern at Microsoft in 1994. They're great videos. If you don't know who Casey is, let me know. Sorry about not checking out CPM. I feel kind of bad now. CPM. Right. Okay. Let me just play this video and we'll get the audio levels kind of roughly.
Internship interview was actually the most interesting question of the 4.
Right. Okay. Enjoy. Thank you. I will be right back, guys, because I'm actually really interested in this video as well. Enough yelling at the streamer today. It's fine. It's always nice to have you around, Ratchet. So I know you're only doing things because you want me to do the right thing. I do respect your opinion on this, especially because you are very good at this. If you're still here, compression stuff. So I am going to use BC 7, and that'll be that until we end up getting to a point where we have to use block. What is it called? Block BC 5 or whatever for the RGB. Sorry, just red and blue textures. So yeah, that'll be that. But yeah, still learning. I'm just like you guys, developing my skills as I go. Yeah, and we'll do a bunch of coding after we've watched this cool video by good old Casey. One of the goats of YouTube right now, when it comes to coding. Anyway.
Question number 3 from my 1994 Microsoft internship interview was actually the most interesting question of the 4. It wasn't necessarily the hardest.
Oh, and yes, I will be on posture talk, so you don't hear me chew. So sorry about that. I should have let you know in advance. Yeah, this is how we go. If you're new to this stream, while I eat, so you don't hear me chew, we watch an interesting video basically, so I can eat my lunch and learn at the same time.
It was actually probably easier than question number 4, but it's much more interesting, and actually in a modern context is really kind of, it almost seems like prescient at the time, or it seems like something where people were doing something interesting way ahead of where the hardware had actually gotten to at that point, at least in the desktop space. Now, this question was way too hard for me. I wasn't really that good with binary. I knew what the different things were, but I wasn't good enough at solving binary puzzles, basically, to do this one on my own or to think through how it would happen. I did eventually get it on the whiteboard when the interviewer gave it to me, but only because they really helped me out. They kind of prompted me and gave suggestions, right? And without that, I never could have gotten it at all. So the background for the question, which is flood fill color detection, is that in those days, graphics libraries oftentimes, at least for things like, BASIC or whatever, or even probably higher end ones, I don't know, I didn't have any access to higher end graphics libraries at the time, but even in things like BASIC that came on home computers, or that were sold in stores, had the ability to do this thing called a flood fill. And a flood fill is just when, you are writing some basic program and, you draw some lines or something on the screen. You end up, I kind of drew like a crooked heart for some reason. You can then pick a pixel and you can ask it to flood fill that pixel with a color. And what it'll do is look at what the color is of that pixel, and it will expand outwards from there, filling all of the pixels that it touches. And this will make it fill in the entire shape. Now, at the time, computers were very slow, and so this was an operation so slow you could watch it happen on 8086s. You could literally watch it kind of go It's kind of fun to watch, but, if you were actually trying to get something painted on the screen quickly, not very much fun. Now, we don't tend to do this anymore because it doesn't really work with graphics pipelines very well, so you typically won't see this in something that's actually trying to draw images to the screen. You might see it as like the paint bucket tool in something like Adobe Photoshop, but you don't see this in graphics libraries. Typically, the way we do this in graphics libraries nowadays is this thing gets tessellated, into a bunch of triangles somehow, and then you send the triangles down a GPU pipeline, and that's how you would fill shapes. So we don't really fill shapes the same way. But in those days, this was very common. Now, in order to do this, this was for 4-color CGA mode. This was a particular mode where you could have 4 colors on the screen, and I don't know if it was like 320 by 240 or 320 by 200 maybe might have been the resolution, but these are very low resolution by today's standards, and only 4 total colors. And the 4 total colors were just like the primary colors or the secondary colors. It was like cyan, magenta, yellow, or red, green, blue, or something like that. And I think it was actually kind of a brown. I don't even remember. You can go look up CGA displays and see these modes for yourself. They're very primitive by today's standards, but that's what we had at the time. And Basic had a fill for one of these modes, and the person at Microsoft who was interviewing me had worked on their fast flood fill algorithm for some kind of Microsoft thing that I think was in Basic, that it was some kind of Microsoft Basic product or something like that. I don't really remember because I don't know the details of that product. He just kind of mentioned it as part of the interview. So in that mode, pixels are 2 bits because there's 4 colors per pixel. That means that a byte, which of course has 4 separate 2-bit values, right? For 8 bits, we have 2, 2, 2, 2. So that means that you're actually going to get 4 pixels in here. There's pixel 0, pixel 1, pixel 2, and pixel 3, all packed into 1 byte. That's how it was stored in memory, and that's how you had to draw to the screen. So if you wanted to fill a particular pixel with a particular color, for example, you had to actually modify just one portion of a byte. You couldn't write the whole byte with a new color. You had to preserve the pixels that you didn't want to touch and just, you'd have to like and them out and or in a new value and write that byte out to update, say, just pixel 2 if you wanted to. So this brought up an interesting challenge for them when they were working on this fast flood fill, which is when you are doing the flood fill, as I described it just before, it's you pick a pixel and anything of the same color is supposed to get flood filled out. So there's kind of this algorithm of doing this fill where you kind of walk through space finding colors that are the same pixel as the one you started with. That relies on some basic color detection. You have to be able to find which pixels that are nearby to you are actually the same color as the one you started with. Now, normally, if bytes, represented a pixel themselves, you'd just be doing, an equals operation on the pixels that were nearby. But because pixels are actually packed 4 into a byte, it means that now you need to do this kind of color detection inside the byte itself to figure out where the colors are. And what they found in making this, fast flood fill was that a key to making the algorithm run quickly was having some way to take a particular byte with these packed pixels in it and figure out if any of the pixels in it matched the color, so that they didn't have to actually go through and figure out which ones did using some kind of slower process. The interview question was, what can you do for that, right? Basically, like, if you had to implement this fast check that said, here is a particular 2-bit color, right? So a number between 0 and 3, basically, that's your starting point. Tell us whether or not a particular byte that we hand you happens to contain that color. So if you think about what has to happen here, we have a color value. That color value is going to be some number, right, between 0 and 4. So let's say it's something like 3. And we know that in a 2-bit representation, 3 is 1, 1, something like this. Then when we look at a particular byte that has this 4-pixel packing to it, if we imagined, let's say there's a byte that has all 4 colors in it, right? And by the way, the reason there are 4 colors is because black was one of the, not having one of the things lit was one of the colors. So if we had 0, 0, 0, 1, 1, 0, and 1, 1, if we had all of these in a single byte, we would want this to return true because there is some way, like our function that does the test should say yes, because there is a pixel inside this byte that does contain the color we're looking for. On the other hand, if we had one that did not, right, so it was something like 0, 0, 1, 0, 1, 0, 0, 1, no 1, 1 value, we want this to return false. So this had to return true, some non-zero value, and this had to return false. So this has to return 0. That's effectively what they were asking me to do on the whiteboard. Now, this has a very easy solution if you know binary but aren't really very good at it. All we would really have to do is write a for I loop from 0 to less than 4. So 0, 1, 2, and 3, loop over those values, and shift this value that we're given down by 2 times the number that we're iterating. We would just shift down into each position. Then we would mask out the top part, right? We just do an AND with, 3 to just get the bottom 2 bits, and then we would check to see if they were equal to the color we were given. Now, this would be fantastically slow especially on old processors where loops were very expensive and things like that. You'd probably want to then unroll that loop, and it would just be a bunch of code. So it would be kind of slow to do that, right? You definitely wouldn't want to write in a loop. You just want to write it out 4 times, copied. But all those shifts are expensive. There's a lot of different ands and all that sort of stuff. So the baseline version of this is not nearly as fast as you want it to be. And the question is, what can you do that actually does that faster? Now, if we consider what is going on at the bit level here, one of the really interesting things, and I don't think I'd ever really thought about this at the time, this is the first time I really, anyone had asked me a question that really provoked my thinking about it. If we think about the operations we actually have when we're working at the bit level, there is one particular operation, which is XOR, which effectively does a bit level comparison. Now, this is not the way I think I had ever thought about it before. But if you look at how XOR is structured, just the way that it actually works with values, if you look at like the truth table of it, right? If you looked at like, oh, I have a 0 and 1 in one of the values, right? And I have a 0 and 1 in the other value. If you look at the XOR, it does exactly what its name implies, exclusively OR. So it's basically if the 2 values are equal, it will not be true. If the 2 values are not equal, it will be true. It's exclusively one or the other, right? So in this case, if it was 0 and 0, we would get 0 because those are the same value. If it's 1 and 1, we would get 0 because those are the same value. If it's 0 and 1, however, in either pair, we would get 1. So if you look at this versus an equals operator, which we don't really have in binary exactly, there isn't like a thing that's like EQ exactly. We don't call it that. But if you imagined the truth table for this like are the bits equal operator, what we would end up with is exactly the opposite of this pattern. In other words, if we look here, we would say equals 0 and 0, well, that's true, they are equal. 1 and 1, well, that's true, they are equal. 0 and 1, not equal. 0 and 1, not equal. When you look at these two truth tables, you realize that XOR is basically not equal to, right? And again, it's perfectly obvious to any experienced programmer that that is true. But to a novice, which I was at the time, I'd never thought about it that way. I kind of knew what an XOR did, but I just didn't ever think of it as being the opposite of equals. So what this means for our problem is if we imagine, again, and we can use our this was a nice test case, right, that I wrote out before, where we basically have all the different colors packed into one. If we look at what happens here, if this is our input, we can pre-construct, because remember, the color we're looking for stays the same throughout the whole flood fill. We can pre-construct whatever that color is, let's say it's 1, 1 again, we can construct.
Yeah, I'm not sure actually. I think he I remember he writes backwards. I think he said he writes backwards and then he just. So he writes backwards to himself, so it's forward for us. I think that's how he's able to do it. Yeah, he does have to. I think that's what he said in one podcast I listened to.
Construct a byte which just has that value we want in every single slot in each pixel. So this is our test, right? This is our test byte that we're using. If we were to do an XOR on these, we will get effectively not equal to, right? So when we look at 0, 0, and 1, 1 here, well, these now become individual because the XOR does not look across bits. But so when we actually look at what we end up with in the result, if we actually do our XOR, we get the exact opposite of the equals. So these ones both become zeros, right? Because they are not different. This becomes a 0, but this becomes a 1 because there is a difference there, right? This becomes a 1, this becomes a 0, so these flip. And in this case, they are both 1s because neither are the same. So again, this is effectively a not equals operator. What that means is if what we're trying to do is look for equality, we want to see if something matches, all we have to do is do the binary not, flip the bits. Now, we effectively have a byte which has 1s, right, because we're going to not these, that has 1s everywhere that our bits matched up. And all we really need to do now is figure out some way of figuring out if we had 2 1s in a particular slot as opposed to just 1 1, right? Because if we had the opposite thing, if we didn't have any that were mixed, we would just be done, right? Because we just go like, okay, is the value non-zero? We're done. But the problem is some of these have like 1 bit that matches and 1 bit that doesn't. If both bits match or neither bits match, we're actually done after the not. But we've got this problem of some that are a mixture. But of course, we have a way of lining bits up. That's a shift, right? We can shift bits left or right, and we can actually produce bits that line up. Now, we do have to be careful here, right? Because if we want to shift bits over, well, all the bits are going to shift over. That means that if we were trying to line up bits so that we could, say, line up this bit with this bit to do some kind of test on them, we would also be at risk of this bit shifting over into this position, for example, right? So what we need to do here is first, we need to mask this off. We need to make sure that we're only going to shift over one of the bits and not allow the other bit to contaminate across the boundary. But again, very easy to do in binary. We can AND this value with a mask that picks out the bits that we want, those first bits. If we have a mask of 1 0 1 0 1 0 1 0, we can pick out just those bits. So for example, we can do an AND of this with this, and we will just get those leading bits. Now we have 1 0 1 0 0 0 0 0. Yeah? We shift this over, and this, in particular case, we are going to be shifting to the right, right? So if we want to move this over to the right, we can now go, all right, we shift these over to the right. This is going to be 0, 1, 0, 1, 0, 0, 0, 0. Now we have a perfectly lined up version with our knotted version, right? And we can do the AND of these two to produce the final result that we wanted. Now, keep in mind that we've guaranteed now that there will be zeros in the first position because this AND knocked out all the other values, right? So there's no way we can have leading ones here anymore. They've effectively been removed by the previous operation. This, as a side note, if you remember from the first part, part 1 of this course where we learned assembly language, you will remember that there are 2 different kinds of shift. And you do have to be careful in this case to do a shift right that isn't going to shift in a 1 if the leading bit is 1. So you want an unsigned shift here, or a logical shift, right? So this is a logical shift here, not an arithmetic shift, which would have duplicated that 1 bit. But those are, again, they're equivalent on most processors. It's not like you pay more for one or the other. So totally the same cost either way. So it's free for us to guarantee there's a 0 in that position as well. If we now do one more AND by ANDing these 2 together, we will now figure out whether or not any of our patterns matched exactly, leaving us with a final answer, right? If we do all these ANDs, you can see that now our bits don't line up here. I'm sorry, I'm using the wrong one. Our bits don't line up here. So we're just going to get zeros in the places where we didn't have both bits matching. But in the one case where they both matched, you can see there's a 1 here and a 1 here. We will get our 1. So the entire byte, all 4 pixels, can actually be tested with 1 XOR, 1 NOT, 1 AND, 1 shift, and then a final AND. This tests for not equals, this turns it into an equals, this removes the values we don't want for our shift, the shift puts things lined up so we can test both bits, and the AND figures out whether both of the bits happen to match. Now, I'm 99% sure that is the solution that the person wanted, and that I ended up doing on the whiteboard only with a ton of help from them. I'm quite certain they left that interview thinking this person doesn't know binary very well, and that was true. However, my memory could be hazy. I don't know if this was exactly the pattern. It was something like this, but I don't know. I really loved this. This was like my favorite interview question of all of them. As I've said before in multiple places, I don't think this is a great style of interview. I think there's a number of reasons why I don't do interviews this way, and I don't think it's a good interview process. But if you put that aside and just think of it as something that was fun for me to do, separate from whether it made a good interview, I loved this. It was so educational for me to see. And if you think about what this actually is, bringing it forward to a modern context, this is basically doing SIMD, right? Single instruction, multiple data, the way we do it now in SSE or AVX or those sorts of things. We're effectively doing that. Packed single instruction, multiple data is basically an instruction set designed around doing exactly this. And the only real difference between the SIMD stuff and this stuff is that the SIMD instructions are built to avoid the extra work that we had to do here. So for example, in a real SIMD instruction set, which they did not have the benefit of using, you don't need to do this kind of thing. You don't need to AND out bits so that when you shift, they don't cross lanes, because SIMD shift instructions automatically don't cross lanes. So they effectively have that ANDing, that getting rid of those cross bits baked in. Now, that's not that big of a deal. It's obviously a speed improvement, but it's not that big of a deal for something like this, because it's doing all these logical ops, which are pretty easy to mask off. It doesn't cost you very much. But you can see why it's a big deal for more complicated things like multiplies, for example, or adds, where you're going to do these operations and bits are going to cross potentially into the other lanes. And the only way to prevent those bits from crossing is to add lots of padding in between before you do the operation, which wastes all these bits. So this is super cool. It's basically doing SIMD without SIMD. Nowadays, you wouldn't have to really think about this stuff very much because we have SIMD instructions, and we very rarely use values that are 2 bits long, right? 8 bits is usually the minimum. So having 8-bit lanes in SIMD, which we have, is all we really need. And we can get rid of things like this. Furthermore, we wouldn't have to do most of this stuff anyway in a modern SIMD thing because they have equality operators. So even the comparison operators we can now just use because they work in lanes. So much more complicated than a modern SIMD instruction set, but still fairly simple, and just really cool that people figured out, oh wait, we can basically do a bulk set of comparisons on 2-bit values by just, if they're all packed in a byte, we don't really ever have to expand them. We can just do all the comparisons right in place by being somewhat clever with our binary. So that's it for question 3. This is actually the kind of thing that we think about a lot nowadays, because even though back then they had to do this stuff without a SIMD instruction set, we now have a SIMD instruction set, and we have to think about this kind of thing all the time, because the SIMD instruction set is actually the thing that is the very fastest for basically everything that you want to do on bulk data nowadays, whether it's copying the data or modifying the data, doing computations on it, searching it. SIMD is pretty much the only way to get modern CPUs to run quickly. So if you like that sort of thing and you would like to learn more about how SIMD works on modern computers, that's exactly what we're about to be doing in my performance-aware programming series, which is on computerenhanced.com. So if you like this kind of thing, please come check it out. We're about to be doing exactly this sort of stuff. There are so many interesting things about SIMD nowadays because the instruction set is all designed to support that kind of thing. Mm-hmm. And so this particular interviewer was way ahead of their time by trying to do things with multiple pieces of data inside a single byte. Nowadays, this is just how we do things. We don't really go sub-byte, but we do things in lanes exactly like that, because that's how the instruction sets are set up. So check it out if you're interested. I'll be back here tomorrow to look at question 4, which is how to outline a circle. This one was a much more difficult question because if you don't already know the algorithm for outlining a circle, it is basically impossible to come up with. The person who came up with this style of algorithm in the first place was pretty brilliant, and it was a pretty remarkable thing when they came up with it, so trying to do it on a whiteboard is basically impossible. However, I already know the secret now, so I will be able to do it for you, hopefully on the lightboard, even though it is somewhat complicated, because I know the trick. So that'll be interesting. And it'll still be a fun problem to go over, and it's a good trick to know because it does come up in lots of places. There are a lot of ways you can use this trick. And so it's a good one to know. I'll be back here to do that tomorrow. Until then, have fun programming, everyone, and I will see you on the internet.
Yeah, definitely worth. If you are really... I've done some of this course, by the way. It's £7 a month or something like that. But it's super high quality. It's difficult, though. As you would expect from a course that's about this type of level of getting you good at this type of stuff, it is harder than like learning C++ or something. Like there's legitimately a lot of things that you have to learn. I love books over courses. The downside of his course is definitely that if you don't have the time to do it, you're just going to be burning £7 a month. So that's what happened to me. I had to take a break, so I stopped paying for it. I took courses for 1.5 years. Damn. This is definitely worth it, though. I'll show you. I'll show you why I recommend it. Is it in the link? I'll just go there immediately. Okay. Computer enhanced. Computer enhanced. You might watch that one at some point as well. Table of contents, right? So this is his performance aware course. But this is stuff that you just don't learn really in a modern computer book, as far as I'm aware anyway. Alright, so this course is designed to ensure that everyone's taking the course has a solid understanding of how the CPU works at the assembly language level. So you're forced here to write assembly, write a disassembler, and then simulate a CPU based on that. And yeah, there's a little extra stuff that I haven't actually covered, but that's how he teaches you assembly. You write a CPU simulator for an 8086 processor, so a 16-bit assembly. In this part of the course, we will learn how to measure time and instrument programs to automatically determine where time is being spent. So this is something I probably definitely need to learn at some point. I think this is free. This one. How does query performance counter measure time? But the rest are paid again. But this is important, right? Because it's you profiling you don't know how fast something goes until you profile it. That's basically that, right? So, but yeah, you get homework every single time, which is the hard part, right? Rather than watching the video, you using a knowledge from part 1 and 2, we look at how data moves on the CPU. We estimate the upper performance limit of our software imposed by need of data. So, yeah, this is So this is cool. Like, I don't know what this would be, but like, you don't get, you don't like typically learn like what page faults are. Like, most people don't even know what a page is. Well, I say that. Most programmers, well, okay. So most programmers who aren't dealing with C and C++ and Zig and Odin and all that kind of thing, they won't know what a page is, right? So it's like, yeah, I just think it's cool. It isn't finished though. There's yeah, so he's added a couple of extra stuff, but it's difficult though. That's the thing. Yeah, part 5 is into progress. I'll stop shilling it. I don't get any kickback. I'm not sponsored. I just have taken some of the course, and it was very good. But it, like, for learning Vulkan, if my main goal is to learn Vulkan, then it's not always the best to go that. Assembly, C, and C++ are my top priorities. I cannot find a book that teaches that well. Yeah, there's a course there that you could do, but I have to admit that, like I said, you've got to be careful diving into that course. It's not for a beginner. I don't know how you'd rate yourself, but I just put a asterisk in this. It's for programmers who have reached a certain level. Because it's not like impossible for a beginner, but it's like, you have to be comfortable in the language that you're going to write the homework in, otherwise you won't be able to do the homework. I'll show you kind of what I did in my homework. Those are taught in computer architecture. I've never done that computer architecture stuff there. So, I don't know what to show you, to be honest, because it's kind of like a boring program, but oh, the CPU simulator. Yeah, I hadn't actually got there yet. So main. So effectively, you should be able to like write this type of code. It's not the best code, to be honest, but it's like knowing how how binary works is definitely helpful. Like, we just studied them with XOR, ANDing and R shift and all that kind of stuff. Yeah, it's on my GitHub, but it's not that, I wouldn't say it's like the best. It's actually it's probably pretty lame compared to other people's. But what I'm saying here is that if you're still not familiar with your language, then this is going to be a struggle. That's all I'm saying. I'm not saying like I've written something that's particularly amazing and it's so difficult that no one else can do it. But yeah, this was all this code was covered. If I go back to computer enhanced again, or wherever it was, or computer enhanced, sorry. That was all this code was for that. Like, all that code was this. It was 1 to 8, and I wrote all this, in 1 to 8, right? So that's why I say it's difficult, because it's quite time consuming. And I was trying to do it well and fast, so I wasn't just trying to like it's kind of tricky, right? Based on my experience, books teach from scratch. The author does well, but then they rush into advanced topics, which makes me confused for good. Yeah, it's part of computer science degree from a university. Yeah, I'm assuming that. Yeah. Sorry, yeah, I understood that you meant computer architecture course would be a degree thing. I mean, he explains everything really well, and I took a load of notes on it in my note-taking thing. A bunch of stuff here. No, sorry, that's not it. As well, sorry, it's kind of like if you combined both performance and assembly together, yeah, there's like a bunch of stuff in here that I had to like understand. I did do a little bit of the more advanced homework, but not much of it. Like, I only did a little bit extra. He does actually say at the end of one of the videos, which is quite funny, after you've done conditional jump, if you want to do the additional homework, decode every single other 16-bit assembly instruction from binary. So, yeah, that exists. What I found is I search and learn by myself, but yeah. Without using any books. Oh, that's cool. Yeah, so yeah, that was just I just wanted to say that on top of me shilling the course, right? I didn't want to I didn't want to send someone who's like been programming for like 4 weeks like on a course that's too advanced, you know. Hey, 52 Gears Incorporated. All right, let me just clean up. I've got like a bunch of food everywhere. Well, containers of food, you know. So I'll be right back. Well, I mean, I'll still be able to shout at you, but I won't be able to read chat. I'm into GLFW. Nice, nice. GLFW and SDL are very good. I don't know what it was with GLFW, but I used SDL first, and I think it spoiled me for GLFW because I was so like I was like, why isn't it just working? Why isn't GLFW doing it like SDL? Because they operate in like slightly different paradigms or philosophies. I don't know. They've definitely implemented the same stuff very well, just differently. And I always preferred the way they did the way SDL did it. No reason. There was no like objective reason why I could say SDL is why I think SDL is better. But it's just a preference thing. Yeah, I'm almost done, guys. I'll be back on my computer now. Yeah, but I've used both. Like I said, used both. So they're both great for both Vulkan and any other rendering thing that you're interested in. OpenGL, whatever. So yeah, let me just almost done. And okay, looks like we're done. I don't know if you guys can hear me from there. I hope so. Otherwise, my neighbours were just hearing me yell about SDL. GLFW is not complicated. Yeah. I think they're both extremely good, considering other libraries out there and how complicated they can get. NAND to NAND to Tetris was a popular resource. I'm not sure whether it's free. Ooh, that sounds cool. Let's have a look. Tetris, and then we'll get back to coding with an S. Never heard of this. So is it a book? Elements of computer science. Nice. So there you go. That might be an interesting book to look at. I haven't heard anything about this. Cool. Yeah, I have no opinion on it. It just sounds like a cool idea for a book. But I assume it's like how to build a. But again, like you'll probably learn a lot if you did this. I have no idea, to be honest. Yeah, cool. Should I be worried? I crashed out 2 weeks ago and started working on my old GUI framework, and now I am making a code editor They keep pushing AI down our throats. Yeah. Well, you know, excuse me. You do you know. You'll never find me ramming AI down anyone's throats. In fact, I pretty much do the opposite. I try and get people to barf it up. Like you're choking on something. Come on, programmer. What have you eaten there? Another AI? No, spit it out. Anyway, right, where were we? Oh yeah, we were setting the size of. Now I assume that depth is R, so yeah. Apparently there's 2 depth textures, so I'm just setting the size of everything. Yeah, so it might be worth just compiling it, to be honest, and just dealing with all the compilation errors. Yeah, so there's another texture here. So what we're doing here is we're moving away from how we were calculating the textures earlier, because we're not guaranteed to use this RGB idea, RGBA with an alpha channel, right? Which is 8 bits per channel, so that would just be the width times height. So I'm just going to do this. Do I have the word size anywhere else? I don't want to shadow by accident. Yeah, this was because we now have block compression 7 being used, and block compression 7, as you can imagine, is compressed. It's 3 times smaller than a texture I'm loading. That's going to go on the GPU, so that's going to be considerably faster. Sorry, yeah, it will be faster. It will be. I don't know how much faster, but it's going to be faster. So we can't just assume that the size is this, width times height times 4, right? We have to do this. So as far as I can tell, for our GLTF load, this is the last one, I think. Then we just send in the total size, which is this fella. Now, we can break everything. I think I'll just call this format now. Get rid of this F. It's kind of lazy to leave that there. We don't need the MIPS because we already work, because the KTX already works them out. We already have MIP maps, which is fantastic. So yeah, it's basically 3 times smaller for this particular duck texture that we've got for our duck, and not only that, it has MIPS. So yeah. Oh, we don't have any music playing. Let me oh wait, and I'm not timing myself. Fantastic. Let's get the music going. Oh, sorry, that's gonna be really loud for you. Sorry, let me adjust that levels. How's that? Let me know if that's good. I fell asleep and damn, you got 14 peeps. Oh, cool. Yeah, thanks for joining us, guys. Yeah, we reached 25 followers too. I'm glad the music isn't too loud. I hope you had a good night's sleep though. I assume you were going to sleep because you needed to. Alright, so, right. Yeah, that's true. We should multiply everything by layer count. Ugh. Alright, we got extra thing to do. Right, I'm just going to compile because I feel like I've missed something. Yeah, it's certainly not night lol. Oh, okay, fair enough. Yeah, I've definitely missed stuff. So let's remove these compilation issues, and this is for the cube map. Okay, so I can easily set the size here. This is not that difficult to do. So size is equal to width times height. All this will be block compression eventually, but block compression is 7. You forgot I'm like 2 to 3 hours ahead of you. Oh, okay, right. I gotta go. Oh yeah, because you're from. Oh, you're from Finland, right? Right, so that's that, and then we can just say, all right. We also need to do the image's size as well, because that is going to be multiplied by 6, because that's the cube map. Close. I'm close. But no cigar, as they say. Width times width. Yeah, I guess we never have height. It doesn't really matter, to be honest. Maybe it's worth doing 64, because this is quite a large texture. But anyway. Let's see the errors that we've got here. Right, so we got this texture, which is... This is the KTXF. Okay, so this is just the standard, same as usual. Right, so that generates the MIPS on the fly. So this will actually probably be faster than my old... than everything, because this is quite, you know, the loops, because I've done this, sorry, because I've generated the KTX2 file offline, we've basically done this offline, so we don't actually have to do this again. Which is nice. So yeah, we can do that. What else we got here? Same deal. Yep, same deal. I'm gonna take this, and we should have everything else the same. Yep. Cool, cool. Now we've done that, let's just see if we get any compilation errors, see what else we're missing. We'll leave the warnings for now because most of them are trivial. Lots of some... Okay, so we missed one. Set size, yep. And this is for a... Oh, the particle... Yeah, same thing. Same dealio, again, for the particle texture. We do have a scuffed particle renderer. uint 32 size equals size. Let me do this and okay. So now set size. We've got one left. So we keep finding them. Okay, we are in right. Okay, so this is the first KTX texture we did. Get size. Sorry. There we go. Okay. Now, yeah, we should cast this to uint 16, I guess. We'll have an implicit cast. Is that really what I want? Yeah, no, this is bad. I don't want to do that. I want uint 32 because the size is quite big. At the very least, yeah. Right, so that should be everything. Okay. We have next. What's the issue here? Oh, I haven't done the... I thought I did this. Ah, right. Didn't change it in the header as well. Let's get some water. Alright. 0 failed. So, now the next step is to go into our GLTF loader, which we've been messing with for our super compressed textures. And instead of doing this here, which is just, you know, silliness, we do have to work this out for So image size and total buffer size are kind of tricky here because we have the total buffer size, which is, you know, technically what we care about. But we're still not out of the woods yet. We might need to do something else. Right. So total buffer size, and then we have... I'll leave this now. That is for basically the cube map exclusively, honestly. So I'm going to say that's going to be fine until we need to get to that point. Right, so I'm just going to go that build. And I think what I'm going to do is start marching from top to bottom with our texture loading code. So, we're just going to go from top to bottom because I did break for lunch. I want to make sure everything's still good. And no, it's not. Okay, so where was that? So copy to image. So what was that texture then? So sRGB. I think this is actually to do with I don't know if it's here actually. Let's just put breakpoints around because I'm not actually sure where that got triggered. I think it is this though. In fact, it's the only case that exists, so it definitely is that. Okay, so this command failed. And it was because of copy to region. It's trying to copy 4 bytes, which exceeds the total size. Okay, so why are we doing this? Interesting. For what texture as well? That's the next question. So what I'm going to do is, if I put a breakpoint here and then we figure out how many... yeah, because there's only one case, but there's multiple instances of this code running, right? So... this is for the dummy texture, which should be fine. What? The dummy texture has got a size greater than 1. Are you... what? Are you insane? I'm a bit confused here because we shouldn't have to do anything interesting with a dummy text. So, for those who don't know what I'm talking about, this is a that's the texture there. That's just a number. It's a white image. It's 1 pixel in size. And for some reason, what does this come through as? It should be 1. Oh, okay, no, it should be 4. No, it should be 4. I just realized my mistake because we multiply by... that would be for 1 value. That would be for, like, depth. Alright. Because if you think it's width times height times the components, so that'd be, yeah, before. We're not actually getting the size of the image, we're getting the size of the pixels in that image. And it's technically 4 pixels, so... right, where are we? And who is this? Right, so this is that. I doubt that we're going to get that error again, for that particular case anyway. Oh, where? Let's just continue. Right, so let's remove all breakpoints. Can I do that live? Delete all breakpoints. Yep. That's my Windows noise. Alright, so put that back in, and then we're just going to... yep, okay, so that worked. Now where are we now? Does this work? Yep. Right, I'm just going to press F5 and wait for the next error. Alright, so we got that at least, so that's the main menu. And I do want... okay, retry. Where did that die? That died here for some reason. Yeah, loading the model. So we died loading the model, image index. Why did it die here? Something null? Okay, so this is null. Huh. Texture image. Huh. I mean, we could just check if this is null as well, but I assume... I'm confused here. Is this... Hang on. Material... Texture... Oh no, it isn't null. It's not null. This is confusing. So it has something. Okay. So it has the it has basis U, which is good because that's literally what we need. As far as I'm aware, though, that this texture, doesn't. I don't think does it really have a metallic and roughness texture? Does it? That's surprising. Okay, I actually don't know. So what I'm gonna do is just throw this into Blender real quick. I don't think it does, and I'm confused why. Come on, let me see that. Okay. Now, I don't know how to use Blender at all, basically. What are you doing? Okay. Because I think, generally speaking, it's one of these things where it's like, if I'm going to spend my time developing myself, it's probably almost always the case better to spend it on programming. So, yeah. But I know some... No, I'm going to say I basically know nothing. I know how to open an asset and look at it. That's basically it. Models out. I don't know if we can actually decompress these textures. Can Blender do it? Yeah, okay, so Blender can't work out this, but I can at least open the original. I've never tried to open up a compressed texture version. So let's just open up the optimized version without the compressed textures and go to shading. So the question is, do you even have a... So obviously it's using physically... What is going on? Why is it all grey? Whatever. Anyway, I'm not that interested in that. What I'm looking for is... There we go. Okay, so it's just loading. Yeah, okay, so the texture is... So the instance of reflection, roughness, it's just these are default values. Yeah, you just do not have that. Why are you then saying that you do? Alright, okay. So this should be null. Let's run this again. Do you know what I mean? Like I'm trying to load a null texture, which makes no sense. That's why the program is complaining. The texture is null. Sorry, the image is null. That comes from this. But I should have been base color, texture. Yeah, metallic and roughness. Let me. Okay. Right, okay, so metallic and roughness, metallic and roughness. We have two conditions here for the same thing. Oh, no, this is correct, okay. Yeah, no, this is correct, okay. but my CGLTF library doesn't know what to do with this particular file format. So, okay, let's figure this out. Okay, so if we type if this guy, and what we're interested in is apparently it says has no. I know is sorry. Texture. Yeah, this thing. Which I assume is just a boolean. Oh no, okay. Yeah, has this. That's what I was looking for. And as far as I'm aware, image isn't the same as basis image. Okay, so that's actually what we need to do. Why are you open still? Oh, that's why. Okay, so I think, as far as I'm aware, if this is true, then we need to load in the basis image. We might kind of improve this in a minute, but just bear with me. In fact, where's this actually needed? Here, so it's a bit lower. Oh, the song is like iconic at this point. Okay, we have this texture code. What do we want to do next? We need to assign a different image, basically. I'm going to throw a dirty if statement in here. I don't really know how to do this any other way for now. So I'm just going to do this. You know, classic, nothing interesting. Put that there. I'll remove the shadowing in a minute. I just want to make sure that we at least have an image index that comes through correctly. And then we just need the basis image, because that's what we're working with. And then we just get rid of this. Okay, so I think we need that everywhere now, as far as I'm aware anyway, because yeah, we need this everywhere because we got multiple textures here, and if they're all in the universal basis basis universal super compressed format, yeah, we need to pull them out differently. So yeah, this might be worth putting in a function because I feel like there's a lot of duplicated code here, but so I might come back to this and try and improve it. But it should all be the same codes, which is not that difficult to fix. So yeah, okay, so that's the... Alright, so looks like we got that. Alright, basis. We have... What do we... Okay, so we just need to make sure this works now. I guess we'll just let it rip and see what happens. See what breaks next, right? Alright, so this model does not have tangents. Right, okay. GLTF pack has removed the tangents. Very annoying. Alright, tangent vectors, tangent vectors, tangent vectors. Now, how do you work out the tangent vectors? Based on the normal vectors. I don't know what direction they need to face. Because obviously the normals are perpendicular to the face of the model, and the tangent vectors are tangent to the normal vectors, such that if there's a dot product between them, they will be 1. So they're basically 90 degrees apart. So effectively, they face the model. They're like point in the direction of the surface, right? Oh, that's really annoying. it's considered it unused data. That's why it's done this. So GLTF pack, for those who don't know, is like a optimization software. So I need to remember how to calculate them. And the reason you'd want to do that is because tangent vectors are annoying to work out. If you get them wrong, the lighting looks terrible. In my code anyway. So yeah, there's multiple ways of working them out, and I just don't know the maths off the top of my head. So we're gonna Google that. Okay. Yeah, actually, let's look at my notes, because I do have a big section on... It's not quite the same, but a normal matrix, right? So I don't know if I have anything there on... because I know normal vectors are basically tangent functions. Sorry, gradients. What am I saying? Let me... Where are my notes on this? Where's the normal? Wait, what? I thought it was here. Oh, yeah, here it is. Yeah, gradient function. So they come from a gradient function. That's obviously the kind of calculated. That's how you work out the normal vector based on the positions, right? And I wonder if I've left some code lying around about transforming code. Can you have a tangent vector in 3D? Wouldn't it be a tangent plane? That's true, actually. It probably would be a tangent plane. I don't know, actually. They are called tangent vectors. In the when I, like, for example, export this, it would say like, oh, tangent vectors. And they do. Let me think. Is it worth exporting this as GLTF so I can actually look at the tangent data itself? But can you have a tangent with 3 components? Sorry, a tangent plane. I think you're right though, like, because it doesn't make any sense to have a vector, because that could be any point. Right. Anyway, mathematically speaking, anyway. But anyway, let's go through it, because I did take a bunch of notes on how to transform normals properly, just the pure maths, because it does talk about the differences between the two, and I was wondering if we can work out. Yeah, so they should be. I might have to open up my old engine, but I never got it right. In my old engine, tangent, because I worked out the tangent vectors on the fragment shader level, if they didn't exist. So, jeez. Right, so let's have a quick look and just see if we can figure out, kind of reverse engineer what they should be. Oh, wrong Visual Studios. Hang on. Use the older one. I can port these to the new ones, but I just haven't. Right, so as far as I remember, in main, is it lighting or main? So you're gonna have to excuse this. This is a bit scruffy, this code. Right. Yeah. Okay. Okay. So no, that's the TBN. So TBN. No, as soon as we have them. So if we go to the fragment shader. in. Yes, we transform the tangent vectors. The bi-tangents are worked out like that. Do I actually work out the bi-tangents now? Look at it. Let me look at my shaders. So yeah, tangent multiplied by... Yeah, I should be normalizing these actually. That is correct. Is it? Yeah, they should be normalized. Yeah, this is wrong, by the way. Don't do this. Yeah, that is true. Like vectors should normals should be the same size. The reason that you shouldn't try to avoid using the inverse of your model matrix to calculate normals is because it will work, but not all matrices can be inverted. So you end up in this bad situation sometimes. Alright, so that's done. But do I do any effort to actually work out the tangent vectors? Because if there's no tangent vectors, then the TBN matrix goes wrong. So I wonder what that even is when you pass in a vector then. No, I don't think I did. Alright, so calculate tangent vectors with normal vectors, binormal vectors, using normal vectors. So there's something in here that we could do, I think. So it's calc 3. Oh, this is where I. So given a function. Okay. So we have unit tangent vector. Okay, let's read this. In this section, we want to look at... Yeah, I never got to calculus 3, so I'm a bit nervous here. In this section, we're going to look at an application of derivatives for vector functions. Actually, there are a couple of applications, but they all come back to needing the first one. In the past, we've used the fact that derivatives of a function was a slope of a tangent line. With vector functions, we can get the exact same result with one exception. Right, okay, so given a vector function of whatever, we call our prime the tangent vector, provided it exists and it's not 0. The tangent line of I want to call this R, I'm going to say RT, right? Even though it's a vector RT. At P is given by the line that passes through point P is parallel, to the tangent vector R prime T. Note that we really do need to require the R prime is not equal to 0. Okay. In the order to have a tangent vector, if we had this, okay, we would have a vector that has no magnitude. Yep. So that makes sense. We couldn't give the direction of the tangent vector. Yeah, okay. Also provided the R prime not equal to 0, the unit tangent vector of the curve is given by so that's just normalizing the tangent vector. But how do you work out the tangent vector? Well, the components of the unit tangent are somewhat messy. So you just take the derivative of the vector function, whatever that means for our case, and the derivative of that vector function is the tangent. Okay, that's not that useful though. For graphics, well, obviously, if you understood all this, by the way, if you got to the calculus 3, like, I'm jealous. You know, what I'm saying is you understood all this like in the past in school or something. There are times you'll need to use the tangent vector instead of the tangent unit vector instead of the tangent vector. Yes, find this general formula for the tangent vector and unit tangent vector for the curve of this thing. Okay, let's just have a look. Can't we use normal vectors to work this out? Like, that's what I'm assuming that we could do. Instead of getting the derivative of like some arbitrary function, because we have no idea like what this is. Like, we can't just say like, oh yeah, this means that, obviously, duh. But like, because our, in this case, vector function is like whatever the triangles are, as far as I'm aware anyway. A tangent of a vector. So I'm trying to work out the tangent vector that comes from working out the derivatives of a vector function. But I want to use the normal vectors because that basically tells... Hang on. Could I... Hang on. Maybe this is just a simple bit of algebra. Hang on. So, if the tangent vector is the normal vector, but at a 90-degree angle, that's it, right? Right, so we're going to have to, like, unfortunately not do this, which is annoying. But anyway, so if we have a v tangent, which is equal to normal, v normal, which is the normalized. Okay. Do we do it before or after the, we transform the normal by the normal? No, we don't. Okay, so tangent is equal to this. And we just need to do a transformation on that matrix that means that the dot product between the two is 1. So if we had... So the solution would be 1 equals dot v tangent normal. And the big loose goose. Tangent vector of what's the... yeah, okay. Maybe we work out everything. Hang on. I might be jumping ahead here. Yeah, we need to do derivatives of the function. This is what this is about. Yeah, okay. That's how you do it. You actually... Oh, this is really awkward. Okay. Yeah, tangent of the model, right? So yeah, we do need to get the derivative of the... It's pretty free though. I remember it being completely free. So we do need to get the derivative of whatever the triangle is, right? And of the vector, yeah, because that would be our vector function in that case. So we need to do like a partial derivative over dx dy. And then that works. It kind of, and then do a bit of maths on top of that, and then we get the tangent vector out. The problem is I'm gonna have to code a bunch of stuff in to even get that testable, which is not ideal, and I just need to figure out what to do with it. Okay, so flags. All right, so what I'm gonna have to do is, yeah, I'm gonna have to use this flag variable. Let me just check something real quick in my fragment shader, because I actually do use this flag variable for one particular case, which is the I don't know if this is even faster now, you know what I mean? Yeah, so I couldn't get rid of that. Let me think. This is the... Okay. Really? What do I use the flag for? I thought I used it for this. Yeah, this thing. That's not used anywhere? No, okay. Interesting. So we've had an unused variable this whole time. What kind of surface? It could be, as far as I'm aware, if I look at this code again. So we take the texture coordinates. Basically this maths, right? Because I know there is something to do, but you've got to... And as far as I remember, df dy is like a derivative thing. So we have to use the text calls and position. I don't really know, by the way. I'm not that strong on my maths. I will admit that. Hands up in the air, court. You know what I mean? I don't know maths very well. I'm working on it off stream. Obviously, you guys won't see that because it's kind of boring. So I just don't know this well enough to understand like this exactly. But I basically want to recreate this so we actually have a tangent and a bitangent thing. And then we can work out the TBN matrix, which is then multiplied and got the lighting. So, does this make any sense to you? EFO, right? I don't know. I don't know if that makes any sense to you. I'm gonna have to like leave this here, but I'll post this in the Discord if you want to look at it. Because I'm gonna have to obviously click off and do something else for a minute. But I'll throw this in the Discord. In the resources, kind of just throw it in GLSL code here, and you can like, you know, look at it closely or something. I think you're in the Discord. If not, there is a link I think on my channel and in the description. You need to make sure that you understand the lighting model in the first place. The maths details come second. Yeah, I think I've got that better. I've got better at lighting. I have been studying that. We spent I spent a whole I don't know how many weeks it was. It was like a couple of weeks just going over the lighting model. So it's not like I understand it completely. I just rewrote all my lighting shaders to do what is it called? The physically based rendering better or differently, you know. Okay, so yeah, so okay, so what I'm gonna do then is if we don't have any flag at all, then I'm just gonna kind of make one. Draw flag. No tangents. Right, so this is a just equals 1. If the material shader is I've returned with energy. Nice. Thank you for joining us again. I'm trying to figure out tangents. Right, so I'm just going to grab this code. Which, you know, obviously isn't ideal, but yeah. Is this 2D or 3D? I thought it was it's 4D. Okay, so it's a 4-dimensional vector. Right, so you guys are going to go... Yeah, so you're going to guys go up here. If you don't have anything, we have to redo the tangents. This exists. Nope. I draw flags. I probably said draw flag, right? Yep. No tangents, actually. Because that's what it means. Alright, so no tangents. Then we have to work out the tangents based on this texture coordinates. So this should be vec2. Yeah. Why would the text code be anything else? V position. And then we have this. Apparently it's taken from this. Well, maybe look up the code in a minute. Normal. Oh, did I explain it? I didn't explain everything. Look, see. So we got as far as we could load the textures, but we can't load the vertex attributes and stuff like that. Is it just a triangle? Is it just some triangle? Is it just some triangle mesh? Yes. So, yeah, so that's what we're doing at the moment, trying to work out the... We don't have tangents because unfortunately, the GLTF pack has stripped out things that aren't used, which according to its own algorithm has been the text chords, which is... sorry, tangent data. Which is unfun, because now we have to work them out again. I don't know how expensive this is either, because it's not free, any of this. I don't think you've adequately described it. Is it just a triangle mesh? Yes. So hopefully that... yeah, keep asking questions, by the way. It does help. Because it makes me think about what I'm doing. So, as far as I can tell, what we want to do is actually not this here. Normal, so there's a cross product between this. So, I think what I want to do here is change this. Oh, this is so scruffy. To that. Where's normal? Where's normal worked out? That doesn't exist. What was normal here supposed to be? Yeah, so that's yeah, that makes sense. That I've definitely seen that before. That's what we were working out earlier. But yeah, okay. So each triangle, has a normal data. Yes. So tangents are computed from those. Yes. No, it's actually I'm lying when I say yes. Actually, it's doing something different. Okay, so I don't know why it's using texture coordinates. I just generally don't know this. Even when I did this for the first time, this was used in here. It was for some reason this was. It was working out its tangents from here. Okay, so what am I saying? So I learned that, like, I kind of just like threw this in because it was just like, oh, okay, this is how you're supposed to do it. But we use no, we do use normals. We do use normals. Sorry, we do use normals. Yeah, sorry, we do use normals. We have to use a normalized vector. Okay, let me just fix that. Oh dear. So n is this. That, I think. Yeah. So we take the normalized vector. I'm just going to talk through this because I don't exactly know. The bitangent could be anything at this point, but if it's not, I don't know what this is going to do. If I normalize, so we should always have normals. There's no. I'm never accepting a model that doesn't have any normals. So we do this, has no tangents, then we work out for, I don't know what we're doing here with the partial derivatives. For texture coordinates, I'm a bit confused by that, honestly. And then we do basically a bunch of, what are we doing here? We're doing a big division. Let me just kind of line this up. So we take, yeah, because we're changing, is that even correct? What? Surely that's dx, not dy. Alright, so I'm going to have to... So each triangle has normal. Oh, sorry, I read that. Is the normal data provided in the texture? It's provided not quite in the texture, but it's along with the texture, if that makes sense. So we have a texture and the texture coordinates. This is worked out per pixel. So we need to know, like, okay, we have a texture. In texture space, we have like a 2D vector that basically looks up like a random, like, well, not a random point, but like a pre-calculated point on a 2D texture. That's what that's for. So for some reason in texture space we get out the derivatives of the x and y. This is the thing I do not understand, by the way. So if this is confusing, I don't know either. And then we do this kind of we get the derivatives of the actual positions of the vertices, and then we do some operation on top of that to get out this. And based on that based on that vector that we've somehow calculated, but with this stuff. So I'm going to actually look up this in a minute, but we do a componentized. No, we do two scalar operations on that. We do a negative with the normal. And then we times that by the dot product between the two. So that's a true scalar operation. And then we can work out the so we don't need to normalize this twice, I don't think, unless we're assigned it anything. So we get the cross product between those two, and we get the bitangent. That's because the texture doesn't store color data, it stores surface data. No, the texture coordinates do, right? Ah, the texture coordinates store surface data, I think. Right. Let me look at this code, because oh, I've already done that. Sorry, twice now. So apparently this was nabbed from here many moons ago. I have no idea where this lives though. So we need to see the shaders. We're just not a fragment shader. What? That wasn't anything. Yeah, okay. BRDF, that's about right. Yeah, okay, so it's got the it's got all the same stuff in here that I'm used to. I'm gonna go a bit slow though. So it's got multiple BRDF calculations. Okay, so this is not quite right. This is not quite what we need. But yeah, that we basically have some of that code in ours. Obviously I didn't copy it from here. PBR, that's probably right. That's probably what we need. So what I'm looking for is I think I might have gone past it. So to do any of this, you need all three. Okay. You need both tangents, bitangents, and normals. Where on earth? Okay, so this is all the values. This is us still collecting values. So it does every type of BRDF, it looks like, but yeah, the 4 different types. There's not that many. I'm not convinced that code's right. Basically, that's why I'm looking in here at the source. Okay. Right, so something... Okay, so we have... Okay, there's normal. So we have a half vector. Where's the normal vector? N. So we have to had... Where's the N vector? So this is the Fennel, Flip, Slick. Okay, so... So the metallicness, yes. There's a bunch of stuff here. And... Okay, so normal info, we have the... Okay, that's the TBN. So it comes from normal info. Where's that? Okay, normal info, get normal info. Okay, so where would that come from? Material info, maybe? Tone mapping functions. Okay, there's multiple GLSL files here. Let's go with material info. Do you exist? Okay. Right. Okay, so get normal, tangents, and bitangent vectors. Okay, so this is the code that was used in the book that I was reading at the time. No, it is. Okay, so it's... Ah, right, that's what I made the mistake. I remember this never working, you see. I see I made the mistake here. I knew that was wrong. I knew it. I felt that's pretty vindicating. Okay. So I'm looking at this, guys, if that's what you're wondering. Because this has never worked right. I remember it just constantly being broken. Right, okay, so, yeah, we take the derivatives of those. And that, I think... Okay, so we need to know where this is actually used then. Okay, so it's here. Yeah. NG. So normals are either present as a vertex attribute or approximated. So that's if you pass in the TBN. And yeah, it's the same thing twice. Okay, yeah, everything else looks good. Okay, right, as far as I can tell, that is as close as we're going to get to something that makes sense. The downside is this well, now I've got to mess around with the vertex shader. Right. Alright, so no tangents, depression ensues. Okay. And we should be able to just nab some of this. And go into the vertex shader. And, okay, so when do we do this? We need both the model matrix calculated. Ugh. Okay. It looks so nice, and I'm gonna have to make it messy. Okay. With if statements. Fantastic. I just don't know how you'd work these out any other way without knowing the surface. Okay. Now we know... Could we work these out on the CPU? Hang on. Is it possible that... No, we need to know this derivative thing. Okay. Maybe it's worth it. I don't know. All right. Well, hang on. Let's just get it working first, right? Let's. So if you have tangents, so if you add these together. Yeah, because that's not going to have any data in, so it's just going to break. So let's set this to a value that's not going to break everything, if that makes sense, right? So we should be able to do calculations on this. This is like trivial. It's not going to do anything interesting. And this is so it can be passed over to the fragment shader. And we should be good. Okay. All to do something I've already done before, hey? Right, next then we've got to work out, based on the model matrix, we normalize them. Yeah, okay, so in fact, do I even have to use this? No. What I'm going to do then is, let me think. I could put this in here. Do I need anything from here? No. Okay. So we take, we need the model matrix for other things. Okay, so what I'm going to do then. No, okay, so it needs to be calculated. Sorry, I'm kind of going backwards and forwards here. But I'm trying to figure out a way to make this like a little clean instead of it being an absolute mess. Because I need to do this here. And yeah, that's what I need to do. Okay, so tangent multiplied by, so we have the model matrix. So we have the normal. No, we have the model matrix. Yes. And what I need to do is, yeah. So if I set, yeah. Yeah, we do. Okay, so we don't need tangent vectors here. We can say this equals to that. We can equal it twice. I don't think that's going to cause any issues. And if tangent is not used anywhere else, then we can say vec for tangent instead. Get rid of this. And then when we pass this value over, it's not going to cause any undefined behavior with like dividing by 0 or something. Because that is a unit vector, I think. Doesn't really matter. Alright, so, great. Next is, so if this is true, then we do this. If not, we just ignore it. And as far as I'm aware, that's the maths. That's how it's done. So if equal to 0, because we've ANDed these guys. Okay, so now we need to go into our GLTF thing, and unfortunately start adding a flag here. So mesh draw dot flag is equal to, alright, so we're gonna have to stick this at the top, I think, for now anyway. I don't really know where to put this, so I'm just gonna put this up here. Const expr, oops, jeez, I've been thinking too hard. Const ex, I keep wanting to say expert. Const uint32. Might put it in an anonymous namespace. Hey, Emmanuel. Draw flag. No tangents is equal to the same as what's in the shader. 1. Equals this. Cool. So now we have a material buffer that has the data in that we can actually say, okay. Oh, I put this in the wrong place. I put this in the normals, not the tangents. That would be silly. Right. Cool. No tangent flags. Now we actually do the maths to work out the tangents. Hopefully, we have the TBN, which is the model, which is absolutely needed for the model for the physically based rendering. And yeah, and I've corrected the maths that was here all along because I know this never really worked, despite not knowing how it actually worked. Well, okay, I've corrected what it should be, but I'm still unfamiliar with it, to be honest. And I think we can just double assign these things. I think we can just do this if it exists. Okay. Okie dokie. Okie dokie. Let's see what the shaders need to be fixed with. So can I convert? So 200 and 290. Cannot convert. Oh, okay. That's pretty trivial. Sorry, XYZ. Oh no, sorry. XYZ. There we go. Should be fixed. Well, that bit, part anyway. Oh, did I not save? Unless there's something else. Oh, true. The tangent is actually a Vec 3. Sorry, a Vec 4. And what was it before then? Sorry, just a... So, tangent... Okay. Let me think. So, tangent needs to be... okay. This is super easy. I just can't remember how to do this. So if you have a Vec 3 and we have a... Is it still the same thing? Give me a minute. 269. Oh no, it's this. Okay. I've missed it. Right. It's crazy how using that H unit head, as it shows that 52% of your project is C on GitHub. Unfortunately, that's the libraries that I've had to import manually. Yeah, it's not good. I'm definitely not writing anything in C. Nothing wrong with C. I actually think it's a pretty cool language. Yeah, it's pretty mad. Right. Okay. I do use HPP. For everything, because the build systems know what that means. It's like generally a good idea to give the build systems as much help as you can, so that's why I've gone with HPP. But yeah, in my vendor code, which is where the external library, like everything's a header file, right? And if we go to KTX, we have, .c files everywhere. So yeah, it's hello, welcome back. 214 Angelica is a cutie, which is your other name. Right, we are doing poopy maths. I don't quite remember how to do this properly, so I'm confused here. What is a Vec 4? I'm getting. What is it? This? I thought position had to be homogeneous, so if I look at this, my old... it's a Vec 3. Yeah, so I don't see anything wrong here. I'm just going to do a space just in case it is this. Build. No, okay, so it's definitely line 260. It's definitely this. So cannot convert from high component vec4 of a float. What are you talking about? Right. Okay, let's just think. DX. Okay, let's just do this one step at a time, right? Okay, so does this work? What part of the equation is bad? Because I can't quite work this out. Oh, I haven't done it. Okay, so it's definitely this part, which is what I expected. Right. It's gonna be harder to separate, but that's fine. So is it this? That's the scalar multiplied by V position, which I think is... Oh, it's a vec... Oh my goodness, I'm so stupid. I'm dumb. Sorry about that, guys. I should have just done this from the beginning. That was my initial guess. For some reason, I've got my position as a vec4. For some reason. So that should fix that. Yeah, pretty much. Vendor code is basically 50% of my project. Yeah, that's oh, let's go with that. I'm not gonna lie. Oh, did I not save? Oh, yes. I need to go rid of that as well. And 72, which is here. Oh yeah. By tangent. Lowercase, and 97. So let's see in the vertex shader. 97. Okay, what are you complaining about? Oh, I'm missing semicolon. Okay, and cool. Right, I'm just gonna head to the loo real quick. I think we'll put Donkey Kong Country 3 on maybe. Yeah, screw it. We can put on what? Which one? Donkey Kong Country 3 or some other soundtrack? I'm tempted to put Merry Sunshine. If anyone protests, I will change it. So yeah, I'll be right back. Let me just do this. I just need the loo. Your real name is Execute, got ya. Okay. Let's keep on keeping on. Right. What's the issue? Okay, we've got no issues. We should then hit... Welcome back, Jason. Who's Jason? Or is someone in the... do you know someone called Jason? Yeah, who is Jason? Who is... We've got to do it. Just before we get back into work. Hang on. I need some help with this. Hang on. Let's see. Who is Jason? And where did he go? We've got to know this! Alright, yes, time to start copying and pasting ChatGPT crap into my code. Anyway. Ask Claude, it gets the joke better. I see, okay. I don't have an account, so I can't be bothered. ChatGPT is the only one that just immediately allows me to talk with a bot. Right, okay, so we should have a... We shouldn't have an assert now. We should have... Right, okay. And that is for... Alright, let's just see what breaks next. Oh, there we go. We kind of got there. That's not right, though. What in the hell is going on with this? Huh? So this dock has had the new upgrade. Or downgrade in this case, I guess. What the hell? Unfortunately my light is too bright. Let me turn that down. So in my... Yeah, so I'm just going to turn down the intensity like quite a lot. So I just need to see... Okay. What the hell? What the hell? What is going on? That looks horrific. It's like the texture coordinates are all wrong. I don't really know. It's like, I don't know what's gone wrong, the texture or the texture coordinate. Let's look it up in RenderDoc. I have no idea. We won't actually know. So let me, let's put this in release. And turn off the debugging. Otherwise it won't work. Shall I explain what RenderDoc is, guys? Shall I do the meme? So for those who don't know, RenderDoc is a tool that allows you to debug what's happening on the GPU. It's if you're new to graphics programming, it's and you want to get into it, it's a tool I highly recommend. Using. It allows for like what it does is it takes your Vulkan commands or OpenGL commands and records them, and then replays them, right, by intercepting them before it hits the graphics card. So yeah, it's actually quite good. So we can figure out, basically, what I'm going to try and do is find out if the texture, by looking at RenderDoc, what it thinks it should be, right? I know what it should look like roughly. It should look like if I open up Blender, and is there a way to look at this texture? Let's go to texturing. Yeah, it should look like this. This is what it should look like. This is like the normal texture. There's nothing crazy with it. In fact, I'm just going to import the original just in case this is actually bad. I actually don't. I'm doubting a little bit. So shared. No, I'm in the complete wrong place. Void. Build assets. Models. Out. Just get the duck. Okay, yeah, so... Ooh, interesting. You see that? What on earth's happened to you? So, actually... Yeah, no, the texture coordinates are all screwed up. What? Interesting. So I think I'm going to find the same thing for... You see the difference anyway? Oh. Didn't mean to do that, really. Yeah. So, yeah, if I open up the... let's see... So the non... Yeah, you can see that... For some reason it thinks all the stuff's down here. Interesting, okay. We'll find out anyway. There's a bunch of other stuff I'm going to have to do to check if this is correct. So I'm just going to copy all my assets into the... Oops. No. Oh, for goodness sake. Whoever uses shortcuts anyway. Jeez. So... Assets. Throw these in here. Should have just copied the folder, never mind. Yeah, so I don't know what this means. Why is it doing that? Do I need to scale it or something? It feels like I do, but I'm gonna take a screenshot and then kind of open up the other one and so I can compare them side by side, because this is kind of strange what that program has done to the model. You know? So Blender can't work this out. No, despite that, hang on. How does Blender know what to do then? This is correct. What did it do? You know? Because it knows what... Yeah, if I don't know why it looks like it's got some kind of disease. There we go. Popular on Twitch. Yeah, it's nice. People are tuning in. Right, let's just see this runs. Should do. Yeah, with the same horrible illness. Whoa, okay. Calm down, camera. Let's go a bit slower. There we go. Yeah, so that's its eye. That's what that is. Okay, so let's look. We still need to look this up in RenderDoc. It is still useful. Because we could end up... We might see a bunch of other stuff as well, like what the texture coordinates are. And then we can like work out like what's happened here. Yeah, vampire duck syndrome. You should definitely have follow alerts, by the way. 29 followers. Yes. Thank you for the follows, by the way, guys. Yes, you are right. I'm being an irresponsible streamer by not setting that up on Twitch, because I keep forgetting how to. I've got it on YouTube, but I still haven't done it on Twitch. So I do very much appreciate the follows, though. You have pushed me over the 25 followers, which allows me to get affiliates. So honestly, I'm very grateful for that. I don't know exactly what that means, but hopefully that means that our stream, I think it allows you to get channel points, which is fun. So hopefully it allows you to do fun stuff like that in the future. Right, okay, so I'm gonna look at that, and then, oh yeah, I don't really need that now. Let's take this one, load this in. I think I can get subscribers, bits, and channel points. Funny thing is, you will have to code channel points rewards. I see. Well, that's fine. Well, as long as the you know, I want to make at least the stream a little bit interesting. So we have, I think we have 3 ducks in the scene, so this should, at least in texture viewer. Ooh. Oh, right. Okay. It's got its MIPS base. Okay. I see what's happened here. Okay, nothing's gone wrong. The MIP textures have been low. Okay, you see this? Yeah. Big difference, right? The MIPs have also been encoded into the texture. All right. Yeah. If people don't know what MIPs are, let me know and I'll explain. But I didn't realize that would happen. If the MIPs are all in one texture, how do I deal with this? I only want one. I don't know. Right. So we have this problem where, okay. So we're doing the same texture sampling, which I assume. Let's just check this. Okay, let's just challenge my assumptions a minute. So if we go to the fragment shader and the vertex shader, actually, it should just be here. Go to go back. How do I see the my? Oh, I've pulled them all in. No, I would see them in the fragment shader actually. So we have. Where are all our? Yeah, that's what I'm looking for. No, it's not what I'm looking for. Where? That's the material buffer. The vertex position. No, that's not useful. That's nothing to do with anything. That's the model position. And no, that's just the scene. Where's the how do you view oh yeah, no, I'm not interested. No. What I'm trying to view is the input variables for this shader. You know what? Because I'm feeling a bit guilty, I'll I'll go into here and thank you guys personally. So so we had, that was 2 days ago. Luminous Moon, Tin Mountain, Gene, and Danny RL. Thank you for all the follows. Why did I say that wrong? Illuminous Moon, Illuminary Moon. Sorry. Yeah. Okay, I'm admittedly getting a bit tired. Maybe I need to stretch. Man. Yeah, don't follow me because I got your name wrong. I'll have to go on my alt account and follow myself, just so I don't feel bad anymore. Illustrate, whatever. Dyslexia's kicking in real bad. But yeah, no, thank you for the and thank you for the subscriptions as well on YouTube. I don't want to leave you guys out. Right, okay. I think that wasn't running. Yeah, I can tell I'm getting tired. Let me just reactivate this. So I'm going to say, yeah, roughly about that. Anyway, let's keep going. Okay, so the MIPs are all in the texture. How do I... Right. Okay, so with block 7... BC7 texture, all textures. So I need to know more about this, I think. Right. Yeah, MIPS. MIP maps. So I'm just going to look through this and see if decode. So how do I just get the MIPS that we're interested? If all the MIPS have been loaded in, I think I've just done something wrong. But then again, how are the Oh, hang on. You know what I haven't done? Okay, let me just try something real quick. I've just realized something. I haven't actually, when I actually loaded this in, and I did the texture loading, I don't think I actually specified how many MIP maps were in it. I have no clue, actually. How do we know? Because I think I've put one here, and I think it's broken in. If I actually say, like, okay, VT, like, get... Let's see what's here. So we get formats. Is there anything else? No. Okay. What's in here then? Is the MIP level in here? Like, how many levels do we have? So super compression scheme, formats, duration is no, it's not a video. Okay, so the texture is, yeah. So I need to know this for the KTX library. KTX to get MIP. Why not use ifdefs to conditionally enable and disable debugging stuff? Yeah, maybe I should have a global ifdef to disable everything. Yeah, that's probably pretty smart, actually. Now you've said that, Emmanuel. KDX, no, not KDX2, lib. That's what I need. Yeah, okay, so let's just check, right? If I put 4 in, what ends up happening to the actual duck texture? I'm kind of curious now. Obviously, it's got more than 4, but I'm kind of curious. Does it look different? Oops. If it doesn't, then I'm going to be... No, okay. But I still need to put this in because this is still not correct. Yeah, and we have data, which is... Where do we get data from? Hang on. Yeah, let's just check, actually. We didn't see base height and base width, so... MIP? Generate MIP maps. Do we need to generate them? What is this? Oh, generated MIP maps. Okay. Okay, so I have a feeling that, yeah, that I need to do that. So this is the generate MIP maps value, which I'm kind of curious to see what the value is. So I'm just going to check what that is. Is it a number? It's a... Oh, it's a Boolean. That's not what I wanted. Ah, right, okay. This is why I was in... I thought it was something else. There we go. Okay, so this is a copy and paste thing over and over again. Generated MIP maps is... Yeah, but how many do we have? I think this would be... I don't know. So you have number of layers, levels... Give me a second. This is very Vulkan based, I think. And I won't know until I go into here and see... Are layers and levels anything to do with MIPS? So what I'm looking for here is this. Where are these used? Okay, that was completely not what I wanted to do. Where was I? It's completely thrown me off. Num levels. Is num levels. Okay. Thank you, thank you. So, num levels. What level? Oh, yeah, okay, so... So when I'm creating this texture... How am I generating the texture? MIP levels. Yeah, everything's just... Okay, everything's just 0, which is bad. Okay, so this is just me not getting this right at all. So at the very least, we need to do... MIP maps. And it is number of... Yeah. Okay, I'm going to trust... I don't actually know... Yeah, let's look this up real quick. Give me a second, guys. I'm just I do trust what you said, but I'm just going to verify it as well, just to also educate myself. The sub-resource image is the next thing I need. That's actually the thing I care about. So level count is the number of... Yeah, okay, fantastic, thank you. That was perfect. So every time we have layer count, see, this is what's happened. We've got MIPS and we've kind of not respected it. And we've said everything. Yeah, okay, so this helps us out a ton. So you've actually never used MIP maps ever. Well, there we go. Okay, let's just check. There's nothing missing here. Okay, so everything else. What's this? Okay, that's... Yeah, okay, this is something else. They're all fine. Okay. And I need to get back to load GLTF, and not this, but num levels. Not layers, levels. Should be the number of MIP maps. So I'm just going to have a look at that and see what that is. MIPS, right? Okay, let's have a look. Oh, we're in, I put a debug in, it's just not going to do anything. Let's turn on the logging again, just real quick. Yes, I am aware that I probably should at some point put this if-def somewhere more convenient. Because it is taking up time, actually, now I think about it, like how much time. So, we'll do that. We'll likely do that next, I think. I'm probably going to end up having... This is like muscle memory I'm going to have to remove. But it's like... Especially when I get tired, I forget where the... I forget where everything is, you know? Because we have defines all over the place that... right, okay, so... Okay. Let's see what happens. So we should have a breakpoint that tells us like how many MIPS we've... Oh. Why are we here? Create texture. You are 1? Why are you complaining? And let me guess, it's not even the texture we care about. No, it's not. Okay, so... where is this? This would be a... Okay, so you can't... This would be a dummy texture, I think. Yeah. Extend it. Okay, so the... What's the actual error here? VK image 2 created with this And extends of this 1, 2, 3. Yep. MIP level is 1 for this. Vulkan states that the I'm confused. So I assume we have to say 0 if the texture is too small. Hello, Mabdo. I don't quite understand this error. For each element of the P region not containing a VK command transfer QCOM in its next P chain, the offset plus the image must be greater or equal to 0. Equal to 0 and less than the number of width for specified image destination. So it looks like... Right, okay, so if I go to my dummy texture thing, yeah, you actually want to see where you're assigned and all that kind of gubbins. So you're telling me that it needs to be 0. I could be wrong here. It might not be this texture, but it could be a different texture. Okay, so VMA is dying because we've got a null pointer exception, or that's fine. That can be null. It's a breakpoint because we couldn't create the image. And this was, I think we've still got the call stack here. So create texture, int it. No, okay, so that, I'm confused here. What does it want to be then? Let me think. What is wrong? So when this happens, we don't have enough the hardware is not gonna... I don't understand though, because it was 1 before. So the VK region exceeds the sub width. Okay. So in that case, I hate the fact that I need to put a breakpoint in sometimes because it breaks the call stack, because then it just puts me somewhere stupid. But you know, that's just how debugging is. Yes, forgive me. I've been going for a couple of hours. How long have we been streaming? Let's see on Twitch. Yeah, 5 hours. So 5 hours of coding. Let's change the music, I think. Yeah. Nah, it's just 10 up. It's sick. Okay. So we have image offset, extended width, exceeded the sub width. Okay, let me think. So it's the dummy texture. It's the dummy creation texture. Right? It's definitely this causing the issue. Yeah, okay, so that's causing the issue. And let's go back. Right, okay, great. So you're going the wrong place completely, which is not helpful at all. Let's try again, hey? I'm fighting with Visual Studios today. Holy. Okay. So it's this, right? So this was what? 1? It always has been 1. Now when I go in here and say, okay, the size is that, which is, you know, 4, which is fine. The base MIP level. Okay, so this was what? 1? It's always been 1. Okay, so let's work backwards, right? So does it still break now? Does it break now? Do you? Yes. Okay. So you're still not working. But we will work out what the heck you're complaining about. This maybe. So again, what was this? So this was 0. I see. Okay. So it looks like I need to do this for this particular thing. This can be 1. I think that's what I needed to do. Yeah. Because it. Okay. I think. Let me think. Yeah, I hope. Yeah, okay, finally. Right, okay, so MIP level 10 exceeded. Where were we though? Well, I thought I had a breakpoint. Let me go to low GLTF because I'm kind of curious about this thing because I don't actually. Oh, we don't get here, right? Interesting. Okay, so no, it's equipped with the uniform. Oh, hang on. Okay, okay. What texture is this then? This texture was... It wasn't the first texture. What texture would this be then? So the format is Unorm, which is not a KTX texture at all. Yeah, so is it? I don't know which texture it is, so we gotta find this out, like working backwards. So there's a lot of textures that it could be, but yeah, if we know which one it is. Then we're good. Then we can actually like do something about it, you know. And yeah, the rest I'm just gonna leave. Okay. So we should have a breakpoint here. Okay, so that's definitely not it, because that's fine. Start. We are here for what? The rock texture. Okay, so the rock texture. I have set you up to... Yeah, okay, so that breaks. And the answer... Okay, so it's the first... So MIP level 10. Where'd you get that from? Right, okay, that makes sense. So this has never worked. Okay, that's good to know. Okay, so the oh, nope. That was not useful. I'm trying to read the error, thank you. Okay, so the copy to image X plus the width 0 exceeds the image width extent. Okay, the sub image. Okay, so let's work this out. Let's go backwards. So as soon as we have MIP maps, this all breaks. So this exceeds. I'm gonna say this is always 0, right? Just for now. I'm kind of curious if it's actually like this is selecting the texture. You know what I mean? I'm not sure. Okay, so this is the... Yes, that works again. 5, 5, 5. Here. What? Oh, I'm an idiot. Okay, we didn't load the texture and I expected anything to work. Like an idiot. Alright, so, if we take that, go here. And I'm going to start removing these. as we go. Okay, so what one okay, it's 10. 10 goes in. Oh, oh, I'm so stupid. Okay, so that needs to go here. Okay, so this needs to go into the actual place where it matters, here. This is never used, and we can start again. Okay, let's start again. I mean, you could throw that in there, but it's more of a test than anything. Right, let's see where this breaks, eh? So at least we'll have a breakpoint here. We'll press F5. If it completely freaks out, then we'll know, okay? Okay, so we got another texture, so that didn't freak out at all. So I'm just going to remove everything else. And no, that did not work. So we have that. Let's get rid of that. Okay, so I feel like setting that to 0 is not correct, though. So we are copying over the MIPS, but we're not doing anything. What does this value need to be, though? That's the thing I'm confused by now. Alright, so I need to look into this a bit more, otherwise I'm making a Vulkan mistake here, and I don't exactly know what it is. So when I set this to MIPS -1, we get like an issue, right? And it's something to do with all this combined. This needs to be a particular value. So -1, which is fine, I guess. Sup? Hi, Foot. Footlog Icicle. That's a fun name. How you doing, dude? Thank you for joining us on the stream. Alright. Good, thanks. What about you? Not bad, yeah. We're just trying to figure out why my duck texture looks horrendous on our duck. So yeah, it's one of those things. Indeed, Kappa indeed. Right, so we'll backspace all this, and we're going to see the errors again, but we need to look up something in Vulkan, right? Because we're coding in Vulkan, as you probably didn't know. You probably did know, that's what I meant to say. And we're getting this error, which I don't think is what we need when I press start on the game. So what I'm trying to do with our lovely Mario music in the background is figure out exactly what this needs to be per MIP level, right? So if we have 10 MIPs, why does this break? You know what I'm going to do, actually? I've changed my mind a little bit. Before we do that, let's just check for 100% certainty that the I wonder if the KTX textures are completely fine and I've just busted it up over here. So I'm going to remove MIP map generation temporarily. Actually, just need to do this. And we're just going to have one for everything other than the KTX textures. So we're trying to work with like super compressed KTX textures to help with load times with our Vulkan application. So, okay, no, it's it's also this too. Interesting. Is the -1 not right then? Yeah, so this just breaks for something else, I think. Yeah, so that breaks for that. If height, width, and depth are all 0, which they shouldn't be. I don't know, I feel like I want to say this is 10, because I'm kind of curious. Let me think. Textures. Not -1. I need to go into here and say... Yeah, so this is just a quick hack for now. Equals 0. If that is true, then 1, else that. So we're just going to bypass that issue, and I just want to make sure that... Oh, sorry, equal to 1. then MIP is 0. There we go, that's what I meant to do. Else, do the regular MIPs. I don't see how what you're doing is make... Yeah, it doesn't make any sense now. I just want to check if we can bypass... Oh, wrong way around. Did I get that wrong? Oh, wrong way. Yeah, gotta... Sorry, my bad. Yeah, don't worry about this. This is just a hack. I promise you this will be removed. Explain what you're trying to do. I will. Can I just throw this up and see what happens? And then hopefully... No, okay, so we're still getting 1. And we've been... Let me, okay. What I was trying to do is just, if... Okay, I think we're in the right place. What I was trying to do with that ternary operation, which clearly I am either too tired or too stupid to use. What I was trying to do with this is just say, okay, just for testing reasons, not for anything else. The MIP levels, if the width is equal to 1, is 0. Else, it's just whatever whatever we've passed in to copy over. Right? That's all I want to do. So if we have this here, and we have... Right, like this. Right, you may look at me and be like, why are you doing this? It's just to... I want to get past one particular initial bug. And see if it breaks for the K2X textures. Because I don't know what's correct at the moment, so I'm trying to figure out what's the correct thing to do. Height's fine. Height and width both being 1 is fine. But right now we're getting an error saying that when you try to say MIPS equal 1... No, okay, that also... Why is it... Dude. I don't understand. Maybe it's not this at all. Hang on. It's this? Doesn't the extimic pen per MIP level? Oh, you might be right. Yeah, no, I think you are. So we need to count by 1 each time? No, wait, hang on, give me a minute. Kappa. Right, okay. Making myself laugh. Oh, this is tricky. Let me just remove my insanity. Yeah, I'm just thinking, should I give myself like a proper break? Because I feel like my brain is slowed down. Are the MIP levels separated with Okay, so straight up, I don't know what this error means. If you can understand this error, I don't know why this is happening. So I don't know if you can read that. Let me throw this into a chat where you can actually, sorry, some text, you can actually read it. Or anyone can actually read it. So, that's what I get, right? Let me get the original, actually. Let me just get the original, because this is not quite what I wanted to show you. Yeah, okay, so this is the original, which is, I think, simpler to work out, so... Just going to throw this in. Sorry about the faffing about, but there we are. Let's close this. So, VK copy buffer to image 2. Region offset. So the first offset is 0. Plus the width is 1. So this is equal to 1. Exceeds the the image sub range. of width extent 0. What? No, I don't understand why that's the case. And this only happens because of the MIP level being equal to 1, right? What I mean by that is if I go back to here, right, and this is set to 1, because I assume 1 MIP level is... Am I being stupid, right? I think I mean... Hang on, let me... Okay. Hear me out, guys. When we have no MIP maps in a texture at all, do we have 1 MIP map because we have 1 texture, or do we have 0 because we have 0 MIP maps, right? That's what I might be getting wrong here. And if I've misunderstood something about like how MIP maps are working, then assigning 1 MIP map to a texture that has no MIP maps in it, for example, then that would explain like why I've been making this mistake over and over again. So sorry, if you want to read that message, let me know and I can throw it into the chat again. So yeah, we don't have any MIP maps for a texture that has... you have 1. You always have 1. Right, okay. So the level count is 1. The MIP level is what? 0, 1, 20, 1,000? I don't know. I don't know what the base layer is either. Yeah, let me look at this. Let me look into this, actually. So I need to read this again, I think. What does this all mean? I need to close some of my tabs, I think. I'm about to explode the GPU. Sorry, the RAM. Whoa, no. Stop double-clicking. Stupid mouse. I need to, like, blow in it to stop it double-clicking. Alright, okay, so let's, Right. Right. Aspect mask, okay, is the aspect VK image aspect bit flag bit, selecting the color depth stencil copied. MIP level is the number of MIPs to copy. If we always have 1, this I can't imagine can be less than 0, less than 1. Sorry. Base array and level count are the starting layer and number of copies of layer. So they're nothing to do with MIP maps. That's the layer. That's the layer count. Okay. All layers. We don't have any layers apart from the cube texture. So number of MIPs to be copied. If we have 1, we always should have 1. So if MIP count is 1, referring to the... Yeah, I don't know. It's confusing. It's very confusing. Alright, I can try it. I just don't know. I don't know what it wants here. I did -1 here, but like that just breaks in a different place now. 30 followers. Wow. There we go. On Twitch. There we go. Thank you for the follows, guys. Thank you for being my little bot. 214. Yeah, it's actually appreciated. It's quite a lot. It's quite nice of you to keep me up to date. Yeah, thanks for the follows. Because it's not updating on my screen, so I only see 24. So we've actually gained a considerable amount of followers, which is very nice. Okay, so I hope my stream is good, right? I hope it's not so super boring or frustrating to watch. Yeah, I remember that from a few hours ago. Yeah, it's Alright, so P copy buffer image plus extent exceeds the subrange of 1. So this breaks on the where is this breaking on this? So this is actually the block compression the compressed texture that we have. I assume that layers work the same way. Yeah, I think you're right. The EFO. Oh, is your name eFool? Is that what you? I think you're called eFool, aren't you? I think it's like EFO and then yeah. Okay. There's one MIP. Its index is out of range. There's only one MIP. Its index is out of range. There's only one MIP. Its index is out of range. Bro, this music of this game is so good. My goodness, bro. Okay, so when we... What is this then? So this is slightly different, but what's the base MIP level? Is the first MIP map level accessed in... interesting. If it's 0... Yeah, okay. Of course that... Yeah, right. So, yeah, it needs to be -1. This just needs to be -1? Hang on. If we start from 0... No, okay. Oh, I'm an idiot, right. Because other people will say it's... No, they'll always say it's 1. No, level count always needs to be above 1. What am I doing? I'm an idiot, sorry. That doesn't make any sense. Yeah, okay, so... What about that, then? But with regular tech, this is not how you do... No, this is not right, either. Right, I don't know what I need to do, to be honest. I think I need to sleep for... I need to go into a cave and study Vulkan and threading and graphics and maths for like 10 years, and then I'll maybe able to maybe then I'll know what I'm doing. I need someone there to whip me when I'm doing something wrong. As penance, right? Anyway. Who knew programming is wrong? Okay, so that was just stupid. What I was doing there. Oh, this is what this is from. My goodness. There's so many good tracks from this, jeez. Alright, right. I think we should maybe end this. The reason I'm thinking that is because I feel like I'm just getting really tired. And I'm just not figuring stuff out very quickly. So maybe I actually do need to like go for a walk or something, because I'm confused on what is going on. After figuring out so much to do with the block compression stuff and how to decompress a super compressed texture, I think we've done quite a lot today. But because I can't figure out MIPS, I just think this is like a super trivial thing. Well, I know that song. Yeah, I keep hearing it in commentary videos. Yeah, exactly. I keep hearing them in videos myself. I can see why. It's a great track. So yeah, that's what I'm thinking anyway. So Sri Code, thank you for joining us for the first time. The sub range looks correct. The index 0 for the base MIP, and the count is max index +1. I think the erroring is somewhere else. Got you. Max index, so the base MIP, and the count is max index +1. So you're looking at that one. And this one is... Yeah, because if we got... Yeah, okay, so this copy... Thanks for that help, by the way. Let's unplug my laptop before it overheats. Yeah, my mental facilities have. I think I need to sleep better. I stayed up pretty late last night. I was playing Stardew Valley. Stupidly. But I think it happens to the best of us. We get caught up in a video game. Right, okay, so the barrier dependency info... I just... Yeah, this all seems correct. I just don't know. Yeah, I think... right, let's just assume that the error's somewhere else, right? Okay, so we know this for sure. If I set this to 1... We know this for sure. If we set this to 0... Oops. And we set this to 1... Then we're not doing any MIPS at all, which means everything just looks ugly as hell with MIPS built in, right? So the copy does work, but we have every single MIP map texture in this duck's texture, right? So it samples over everything incorrectly because there's no... The image itself has multiple MIPS in them, and it's baked into the actual texture itself. As soon as we start saying that, oh yeah, the MIPS are these in the GLTF loading code, we say, oh yeah, okay. Well, let's just put a breakpoint here to show you. So we've loaded the texture, right? It says it has 10 MIPS, right? Because it's generated from a KTX2 file. We transcode it to block 7. Block control 7 or whatever. The format is, there you go, block control 7. Then I say, okay, in here, MIP equals like 10, right? Then it goes in here, then F11. We step through, and I think let's just check everything else is good, actually. Right, because I've been skipping over this over and over again, but I might have got this wrong. Yeah, so we're not going to make it cube compatible. So we have MIP levels, yeah. So this is 10. Yep. Then we go in here, we can create this VK image. We set a name, so if it goes wrong, we know why. Then we set the image view, which doesn't really have anything interesting in it, I don't think. Ah, right, okay. There we go. Level count. That's where we're going wrong, I think. Our image view doesn't have this data in. So let's start again. Let's just make sure there's nothing else. Okay. Right. So that's going to help us a lot because the metadata around it is only a VK. So I don't actually know if we've done that right. So, but I think that was a mistake. Yeah. Okay. So that didn't error out at least. And do all this. We create a buffer. We set up a one-time done and run and done. So level count is 10. Okay, that copied. Okay. So we haven't submitted it yet. So I don't think there's anything gonna. Oh, there's another. Okay, so that's where it goes wrong. It goes wrong literally here. Okay, so you are copying the smallest MIP with this command. If I spot that correctly, if you need Need multiple. Oh, do you? You need multiple of these fellas. Right, okay, so is that what you were saying before, E4, I think, in the YouTube chat? There's only one MIP. Right, okay, so thank you. I think someone was trying to tell me that. It didn't quite sink in. Right, so interesting. So we can build up multiple of these fellas, I guess. That makes a lot of sense as well, actually. Yeah, so okay. So we need an array of these guys. I'm gonna make it hopefully stack because I don't think it's gonna be that big. Regions. So we int it, sorry, regions, int it, allocator, memory, service, instance, scratch allocator. So I think because of this, it's going to be quite straightforward. Maybe initial size of 4, I guess, because that's the minimum anyway. And then for this, right, uint32, I is equal to this, I is less than image size. Hi, bot. I don't think that's the reason for the crash. So the crash is something else. I don't quite spot what is crashing. I see. Yeah, thanks for the carry late on in this, late on the in the final stretches. By the way, right? Okay, so MIP map levels. Right. Okay, so I assume that's the case. And okay. The problem is I don't think this is correct, right? Now we got to work out the offsets, I think. Yes, that needs to match. Yeah, match the MIP size. Yeah, that's what I was thinking. How do we get that? So I keep blabbering. So bot has said I keep blabbering into the stream, not knowing it had ended 2 hours ago. Okay, fair enough. Yeah, that's funny. All right, so how do we get this out? Yeah, because our texture, I think we can still have it. This is what our texture looks like. So how do I know what is what? And how do I know what the offset is? Oh, of course, it's a power of 2, isn't it? Yeah, I don't know why it looks like this in RenderDoc anyway. Oh, never mind. Yeah, it's kind of strange. I don't really know. I wonder if we can get the MIP levels out of this compressed texture. It's a compressed thing, so it's kind of tricky. Alright, so I think I'm just going to do this real quick. Data, and then we need MIP level count. No, we need the size of this fella. I think. Okay. When we do a data compression on this texture, what ends up happening to the texture's MIP map levels and all that? What's a MIP map? Well, I can actually show you because we have a texture here, right? You see this here? This texture, just this part, not this bit over here. This is the original texture, and it allows we store smaller versions of that texture over and over again until it gets like tiny, like over here, like tiny little textures. And these smaller ones are mipmaps. So these mipmaps allow for nice. I wonder if I can show you. Actually, I've got a good picture. I wonder if I've got it here. Did I have a... Yeah, give me a second, because I've got like a good picture that I can show you actually, like what mip maps actually does. And then I'll get back to coding, because I want to make sure everyone's on the same page at least. Right. If you just bear with me though, I'm a bit. So it's drawing a triangle, I think I'm looking for. Yeah, okay. So I'm just going to scroll down because I don't remember where I've put this, but I know the image is in here. It's quite far down. But I don't want to go too fast and miss it. Nope. So I'm just looking for images. Nearly there. Unless the image is not here, which would be... Ah, no, it's in texture loading. I apologize. It's in this one. Because it's about textures. Ah, do I have a good picture? I thought it did. No. No. Oh. I swear I used to have it. No, because that's the... That's the other way around. That's the... Yeah, let me... Okay, let's just look it up online. Mip, map, textures, right? So it helps with, like, nice blending. Yeah, okay, that's this is the better one, right? So it helps with this idea of that as we get further away, the textures don't do this, right? Because it's the big, it's like we use smaller texture, we sample from smaller textures as we get further away from the camera, and it kind of has this nice effect where the textures don't do this horrible kind of blending thing that's going on here. They kind of like blur together, and you can see it here as well. Like we get like a bunch of like pixely stuff. So that's what it's trying to do. Anyway, yeah, I should have just done that to begin with. So yeah, that's why we need smaller textures. This is actually something slightly different. For when the for when things get, I don't know what on earth these resolutions are, to be honest. The problem is I don't understand why it's compact this way. I don't really know how to copy each mip map with a blocked compressed texture. But yeah, I didn't even know I had to do this, so this is actually really, like, this is actually a big step in the right direction, because I don't know what the offset is. I mean, you know what? Let's try it. Let's bit shift these MFs. Okay, we can't do that. There. Maybe it's just RenderDoc, you know? RenderDoc doesn't always know what's going on. And I assume it is truncated on the rule of 2 rule, right? And the depth, I think this depth is just the same. So, uint 32. I don't know what the offset will be, though. That's the other thing. But at least we can try, right? Mip width. Okay. And we can even just put in a breakpoint in here just to make sure it works each time. I'm glad you get it, dude. I'm glad I explained it well enough. Right, so the original is... Okay, so this shouldn't break. This should be what? Yeah, because it originally is 1. So this should be at... Oh, I didn't add it. Sorry. Let me push that back. Into here, region. We should have now in regions an array. I'm just going to make sure my array stuff works. It should be fine. Alright, so let's see, regions, data. Yeah, so it has the stuff in. Yeah, okay, that's cool. We can only see that for the first one, but it's just fine. So, okay. Now let's go back to here and re-attack this. Honestly, this music is keeping me going, I'm not gonna lie. Alright, so right, okay, so keep going, 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 keep going. Right, okay, so we have 10 of these MFs. And we have what? 512, 512. And we push that in. Then, yeah, we have 256 by 256. Alright. Let's see. Oh. That worked? Or is it the next bit? That's a pipeline barrier. Let's see. Ah, it seemed to work, actually. Did that work? I can't imagine that worked. No. Okay. Sorry for the wall of text. Ah, no, it's a problem. If you're viewing something close to the camera or your eye, the area covered by the angular resolution is small. So you may use large textures and it won't alias. Yeah. However, if you view something far away, the area for the angular resolution is large, so the light reaching the same pixel would come from different places. Okay, so you use mipmaps to replicate this effect. Ah, there you go. Didn't know that. Okay, where the final visual is an average of things you're looking at. That's why mipmapping. That's why we're mipmapping things. Thank you. You know what I'm going to do? I do this sometimes from time to time. I'm just going to take your text here because this is actually like a really nice. I'm going to take that. Thank you for that. Actually, that's really nice. What I'm going to do is I throw this in my notes and I will make a note on that properly. I do this from time to time. There's someone else's. I think I've already made a note on that, so I might remove that in a minute. So your name was C. Okay, cool. Thank you. Get rid of that as well. So I clearly could explain that better, meaning you explain that better than I did. And I think you understand this better than me, so I need to drill that in my head as well. Cool. Thank you. Right. So we are... Okay, everything is working. We do have mipmaps working, but I don't think this offset is correct, you know? So I'm kind of curious. If I... If I take... I don't know what to do with this. How do we work out the offsets of mipmaps? Yeah, so I need this. I think. Is that right? Sorry, wrong. Let's close this. And... No, that's fine. Yeah, so I actually need to Google this guy. Because I need to know how do you work out the offsets per MIP map? So we're not quite there yet, but I'm kind of, I think I'm getting there. No, that's not it. Oh, sorry. No, it is that? Okay, I'm flipping heck. Bloody hell. My brain. Excuse me. My brain is absolutely... Okay, so offsets. Okay, so there's the initial XY offset of a texel in the subregion of the resource or the destination area. Okay, that tells me exactly what I thought it was, and it doesn't tell me anything else. Right. I don't know how on earth... Okay, what would the offset be then? Maybe... I'm just going to guess and just see how it affects the texture and just say, okay, so the total image minus... So... Okay. So, sorry, the MIP width. This might be completely wrong, but I'm kind of curious to see how it works if this is the case. Why are you complaining? Oh, it needs to be an int. Okay, fine. It's going to be negative for some reason. Right, so MIP width minus this, right? I know I'm kind of hacking this together at record time, but I'm kind of curious to see how that affects the image that we're going to see on the screen when we copy when we copy from a different place, right? Outside of that, I have no clue. So that's more why I'm doing this. Okay, so the copy region. Okay, so all the way around, all the way around, all the way around. Okay, yeah, all the way around. All the way around, yes. Oops. There we go, okay. Yeah, this Mario Galaxy music is hard carrying. Okay. Let's just see, let's just see. Okay, so this is... Okay, so that just does not work. That's not how it works at all. But I don't know. How do we know? Okay. I think the image offset and the extends should be what you had before. You might be different in the place you are copying on. I don't understand how your memory's laid out. Okay, so okay, let me go over that again. So I think the image offset and extend should be what you had before, which is okay. This is what we had before. What might be different is the place where you're copying them from. Okay, but I'm not 100% sure. Yeah, you might be right there. Like, where do we copy them from? I actually don't know. Right. So yeah, let's just check the other variables. I actually don't know what they do specifically. Do I have this here? No. Okay, so we have the same thing open 3 times. Let's minimize that. Yeah, there's what you're copying from. Thank you. Right, this is cool. And I'm just gonna look into the documentation for these particular things too, and we'll have a look. So okay, so the buffer offset is the offset in the buffer from the start of the buffer object where the image is copied to. Row length and the image height specifies the texels are subregion of a larger 2 or 3 dimensional image in a buffer memory, and control the addressing calculations if okay, it controls the addressing calculations. Okay, if either of these values is 0, the aspect of the The aspect of the buffer memory is considered to be tightly packed according to the image extents. Okay. I'll grab a cup of coffee myself. Yeah, thanks for the... Yeah, I might need to grab coffee myself as well. Well, tea more than like. So buffer, offset, buffer length. Yeah, okay. Alright, so... So the buffer offset is... The buffer offset is the offset into bytes. I don't think that's it. Okay. Row length and image height is specified in texels, the subregion of the 2 or 3 image. Okay, let's just do something a bit weird then. I know it seems weird, but obviously this is wrong, but I want to see, you know, a subtle, like, what does that do? This will only happen, that'll be 0, no, hang on, that's not going to work. Oh, no, it's fine. Oh, what? Must be 0 or greater than or equal to greater than. Interesting, okay. Right, so this music is too good for what I'm doing right now. Holy, it's making it sound like it's the most important thing on the planet. Okay. Right, I think I need like a general idea of what this. So how to copy MIP maps into a buffer Vulkan, right? Sorry, how to copy a texture with MIP maps into a buffer. I say Vulkan, yeah, that's basically it. I wonder if this is all. Hang on, let's just check. This might be in the how-to Vulkan tutorial, because I just want to see like what I'm missing, what's going wrong. I wonder if he does, because he's done a lot of like texture stuff, right? And I'm curious if, yeah, so num levels, yeah, okay, that was correct. So the sub-resource is what we've already done, which is the image view, which was the thing we missed earlier. And now clearly this KTX image is likely to have so when we create a buffer, which is what we do here, we create a buffer with the same thing. He just does an image copy because he's mapped the memory. And then he sets up his buffers, his command buffers. His sub-resource access mask is, yep, that's fine. That's what we've done as well. And that is for his image memory barrier. Then he, yeah, okay, so this is what he's done. Ah, right, okay, so get image offsets. Okay, so there's something else here that we need to do. Okay. Okay, so yeah, I thought he had done it, right? So okay, so we can steal this. We don't steal, we become inspired by code. So get offsets. So sub resources, we have aspect mask, MIP level. Right, okay, and level count, which is fine, this is 0. Width is this bit shifted. Yeah, that's fine. Height is bit shifted. Yep, okay, so the Okay, so this... Okay, so we do have a function that we can use. Okay, fantastic. Okay. Right, so I'm going to just kind of see if I can just throw this in and just for the last 20 minutes, let's see if we can do this. So, because I'm not entirely sure what this value is, I feel like we need to have... I wanted to avoid this completely, but let me just add in a class KTX texture 2. Whoops, not a pointer. Oh, that's not how you spell texture. That's really not how you spell texture. Texture 2. Okay, so I completely missed this when I was learning this tutorial because I kind of skipped over it thinking that I need to do other things first. Is equal to null PTR, so hopefully this doesn't break everything else. Right, so you go to the top, and we're going to throw in include ktx.h. I don't know if we need the Vulkan stuff, but hey, we will keep working on this. So ktx to texture to texture. Let's see ktx text. Yeah. Yes, I am live. I was remembering you. I am live. I am alive. Oh, I put in the wrong thing. Whoops. Okay, that's it. Yeah, I'm gonna do that. Just to make things more difficult on myself. Right, why are you complaining? You're complaining because of that, right? Right, why? Okay. Right. So, we need to call a function called... Oh, I'm so glad I stream sometimes because honestly, I would not have solved this if I didn't have, you know, so much help. It's honestly really nice. Okay, so that's completely... I think I need more includes. Okay, so let's get rid of this now. So we need the red code, I guess. MIP offset. Okay, so that's just the KT size. And that needs to be assigned to the buffer offset. I see. Okay, so let's just throw this in here and do this. And this then goes into the buffer offset. Okay, so this is what actually needs to be done. This is why we're doing this the whole time. I don't know why we have rec code with nothing done in it, but that's fine. So for some reason this is a... J is undefined, yes. I don't know why it's all purple. That suggests that it's macros, which I don't know why. What is happening? What is this? Does it know what this is? Okay, so it's just a big define. Okay, so we need the Vulkan include. Alright, cool. You don't know what... Right, okay, so we need all this. Yes, thank you, Psycode. That's exactly what's happening, I think. They sometimes also use irregular mip maps, which I think may have happened here, judging by the render doc. Yes, you should also need to query the KTX texture for both buffer offsets and MIP resolution. Okay, MIP resolution as well. Okay, that's good. So we have this macro here. I don't know what's wrong. KTX2 is incompatible with KT. Oh, for goodness. Oh, that's why. Doofus. Okay, so what's the resolution then? Let's look. So I was looking at this and resolution. Oh, you mean yeah, MIP resolution is. I think we worked it out earlier. Is there a GIP resolution? I don't know. Let's see. Oh my goodness, this is so... MIP or something? Hang on. MIP. Map. I don't know. Hang on. I'm skipping over functions. Okay, and okay. Right. Let's give this a shot. Okay, so hopefully this doesn't break everything under the sun, but we'll see. The code you looked at just assumes that the MIPS... Okay, so we got... what have we got here? We got a linker error. Sorry, let me read your comment. More for educational reasons why I'm not using VK upload EX KTX texture thing. They sometimes also use bit irregular bitmaps. They can also, judging by the rent. Yeah, okay, so I read that. They are just doing a... The code you looked at assumes that uniform bitmaps. You can give it a try. Yeah, I'm just going to try and give it a try. If it looks different, then we know we're on the right path. If not, then we're going to have to like figure out what to do. Maybe we'll even look inside that image. Sorry, in that function, I meant to say, that eFool has said. I assume that's your name. I'm not being calling you a fool for no reason. Okay, so we have... What is wrong? I don't actually know. Texture handle... Referencing in function... Can't you just assume, based on the fact that I've given you a default argument, that you just need to do this? I'm a bit confused, to be honest. We're not using that version anyway, so we need to buzz this in. Let's actually pay attention here. At the very least, can patch that in. Alright, so let's obviously build that again. You might have... How come you guys don't know what to do? Oh, maybe... do you need KTX as well? I'm a bit lost here, to be honest. Why you guys aren't linking? Yeah, okay, fine. So Skybox and particle renderer. It's because that duff. I know it's because I did a forward declare. Love your content, bro. Thank you. Let me just get to this and I'll read people's chatteroonies. Skybox, where are you? Let's go to the top. 33. That's all now. I'm answering easy questions because I can do that while I'm... Let's just see what happens. Please don't. Validation error. Okay. Right, okay, so we've got somewhere. I'm kind of happy with that progress. That shows that we're on the right path. That's all I wanted to see. I just wanted to see, are we going the right way? You know what I mean? Obviously, I would prefer it if it just worked, but that's progress. That's progress. So the code, I think you're right. It assumes that we've got uniform mip-maps. We definitely do not. The code you looked at, just as, yeah, it's a fake word. I don't know if it has a proper pronunciation, but people say psi, a psi. Ah, okay, yeah, psi code. Yeah, I'll call you psi code. Thank you for correcting me. Yeah, okay, of course, yeah, it's the beginning of science. That makes sense. Yeah, if you stick around long enough, you'll find out that I just completely butcher everyone's name. I honestly, it's, yeah, half reading messages mixed with dyslexia and sometimes getting tired. I'm going to say some absolute bonkers names, honestly. So yeah, thanks for telling me how you would like to be pronounced. Okay, so MIPS are not uniform, so the way we're offsetting them is bad. I don't even know how. I didn't know she also skip some large chunks of text messages yet, and then I have to read them again. So I'm like, I'm pretty rubbish reader, you know. It's like English is my second language sometimes. Honestly, I tell you. Right. Okay. So what we need is MIP offsets, I guess. Oh no, we've done the MIP offset. Sorry. Let's look into how. Yeah, let's look at this VK upload function and actually see what they're doing, because I completely forgot that existed after I looked it up in the tutorial once and didn't think about it again. So they obviously have to deal with the fact that the textures are. Oops. Let's get inspired. Okay, so how do you do... Oh. Yeah, with a sub allocator, sure. So obviously you have to do some Vulkan, so... yeah, if it's a cube, then you do that. That's just fine. Get format, so it does basically the same stuff we do. Generate MIPS. So what are we doing here? So you're doing a bunch of, yeah, just basic stuff, sampling, making sure that's chilling. Right, so KDX2C, I don't know what that means. What is this? Okay, so I assume it has row padding, because I just want to pray that is a thing that we have. Tiling optimal, which is kind of what we want. So so the copy region is peak at definition. So, oh, it's a UN32. I thought it was something interesting. We need to see the so it's using its own allocator. Hang on, did I miss it? Okay, and this is what we need actually. So this is the okay, so it's what is this? Give me a minute. Okay, so this is not what I thought it was. Okay, that's good. I don't want to go too fast and skip it. Iterate levels. Iterate over MIP levels to set up the copy region. Oh, okay. What are you doing? Right, okay. Yeah, because I don't have version 1 here. Right, okay, so this is the... Okay, so this is what we're interested in. Right, so it says the offset is... What? Okay, so that's a KTX, okay. What is this for? The data offset. Retrieves the offset of the first levels of the image of the KTX data. Yeah, so it seems to do the same thing we're doing. So width, height. But then it does this data plus offset. For arguments. And this is for an iterator that's going to be spat out. Okay, so what's the... Can we see anything about this or... No, this? Know what this is? Okay, so... Move down a bit, please. No. No! Can't see anything. Alright, well, fine, we'll leave it up there. It's better than nothing. So the 1, 2, 3, 4, 5, 6, 7th argument. So 1, 2, 3, 4, 5, 6, 7. The actual pixels, interesting, is the level plus the texture itself, and that is for the pixels. And if I go back to it, no, this, we have a function call. Where's the pixels? I just want to find the actual VK. Okay, what is this? Not chat. VK. Okay, it's the create image. Okay. I'm just going to skip a bunch of stuff because I have no idea where... I need to see where the things get actually loaded. That might have not been it, you see. I'm going nuts. Okay, let's look at the code. Hang on. Let's look at my code anyway. Sorry, because I've completely forgotten what we're looking for. So we need to find the image extents, right? So if I go back to this, go back. Where on earth is that? Okay, so here it is. Optimal tile callback. Yeah, okay. That's not useful. Right, okay, so we need to find this function in... Ah, okay, so it is this. And obviously this is now 2. Okay, so we already had that. That's so complicated. I've lost it now in my head. So in optimal, it is the width, height, depth. Okay, so that's all I care about. At the moment, anyway. And the region is offset, and the face size, LOD. Now, this is something we worked out earlier, isn't it? Oh, okay. Let's pause that for a moment. Okay, just as a side note, I personally never found a use case for irregular mipmaps. I don't fully understand their use case, and I completely find to just have halved the resolution ones. I know what you mean. I think it's because of the compression that I've used on the texture itself. That's why it's all like kind of lumped together. So I think that's what has happened. I can't exactly know. All right. It is 5 o'clock. This is typically when I end stream. So I'm going to end it here. Thank you all for everyone who's watching. Thank you for all the subscriptions on YouTube, and thank you for all the follows on Twitch. Thank you for all the likes as well on the YouTube side. Thank you for all the lovely comments and stuff, and keep me company. I will just pause this briefly. I'll see you in the next one, and I'll keep on working on this. I will try and get better at this, and so we come back to this and know what's going on. A bit better. I appreciate everyone who's helped me out as well. It's honestly very much appreciated. I will yeah, it's all good stuff. So yeah, I'll see you soon, and take care, guys, and have a good rest of the day, whatever you end up doing. Yeah, GG's.